Welcome to APEC Open Mic. It's January 4th, 2025, and I'm your moderator, Tim Ventura. Thank you, everybody, for joining us on today's call, as well as everybody who is watching us on YouTube. So, as a reminder, today's session is for open discussion and ad hoc presentations. We really don't schedule stuff in advance for open mic. We do have attendees who reach out and ask to present. Today, that is Dr. John Brandenburg. So I'm going to launch right into that, but I do want to start with a couple of quick reminders. You can view conference replays, details, and speaker info on our website at altpropulsion.com. And during these ad hoc presentations, please try and save your questions for after the presenter finishes if possible. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. You can also type questions into chat. We will try and get to those as they come, I guess. So again, Option Y on Mac or Alt Y on Windows. That is the best way to get those questions out there. So let me admit everybody here back into the room, remove the spotlight. I will put it back on this. And again, John Brandenburg reached out to us earlier. He has one about panspermia, which is interesting for me because I'm actually working on a story about that right now. So
I have an update. We're just wiring this up. Tim, if you give me the full screen, I could show everyone some.
Yeah, let me do that. Let me hand this over to Mark.
Okay, so many of you may have heard of the 3M invisible wall experiment. Over here at Falcon Space, we've tried it on small scale on 2 different occasions already, and this is our largest version yet, and it's built out of Kinects. These are like a kid's toy that are they're kind of geometric and lightweight plastic, and that's the perfect building material for anything that involves high voltage because it's plastic, it's cheap, and lightweight. So basically, the 3M invisible wall was an event that occurred in 1995 in a plant where they were unrolling plastic polypropylene in that instance. And on a very hot, humid day in August of 95, I think it was, a electrostatic field built up. They didn't have things grounded properly. And the electrostatic field built up between the rollers, and there was a force field. Anything you threw at it came bouncing back. So in our setup over here, we basically have Kapton. This is not tape. This is Kapton film, 5 millimeters thick, and it's rolling around in a circle. We got lots of humidifiers coming on over here. It's basically stovetops with water on top of them. We've got 4 of them cooking simultaneously. The humidity in the room is around 58%. So it's not quite high enough, humid enough yet, but we're getting there. But we are at around 85 degrees. And in order to detect whether something is actually happening, I built this other apparatus out of Kinects. Josh over here, off from the Navy, is going to demonstrate for us. Can you put a ball in and show them how it works? Yeah, so basically this is a calibrated ball drop test. I call it the ball dispenser. And there's a little trigger there. He's going to trick the trigger. And so it precisely bounces it around the same spot each time. And we're going to get a video of exactly where the ball fell. You have another ball you can drop in there? Yeah. We have several different types of balls. We got ping pong balls. We got golf balls. What are you doing now? Ping pong? Yeah. Okay, we're going to do a ping pong. And we also have bouncy balls, like rubber balls. Yeah. So it bounced right around where that what is that? A needle nose plier that I was using before I put on the grounding plane. And now we're doing a golf ball. So it's a different density, different material, because how it reacts with the slope, it goes a little farther. But this gives us a calibration test. So once we power this baby up and see where it goes, we'll know whether there's any effect at all. Now, we just got a couple more wires to go, and the humidity should go up a couple ticks before we run this thing. But there you got the Kapton spinning around. It doesn't do it justice, but this thing is spinning around like twice a second, 20 feet, 40 feet a second. You got a 24-volt motor there. That's a motor that they have on like little ATVs or scooters. Okay, so we're pretty close to getting this thing running. Jeremiah Pop should be in the audience. He has run a similar version of this, but in much smaller. And he'll be doing a demonstration showing what he got in his results. I think what they ended up seeing there with the smaller version was it would short out before any effect was noticed. Hopefully with this larger version, we'll get something better. And I should have the demo ready in the next half hour, just getting the humidity up and have the final high voltage connection to hook up.
Mark, what voltage will it be running at?
So it's kind of like a Van de Graaff generator, the way it works. So although I'm going to put on probably 30 or 40,000, it's going to build up to way higher than that. But because of the high humidity in the room, the environment's going to act like a leaky dielectric. So the electricity is actually be traveling through the air as it rotates around this device. And the effect was only seen at the 3M plant when they both had a high electrostatic field rotating around and high humidity. So you got to have these two things. You got to have electrostatic rotating field and the high humidity, which would act as a leaky dielectric. So this is our latest version of how we built it. It's about 6 feet tall, 6 feet wide, all made out of connects. We put it together in like 2 days.
What voltage range can you measure?
So I have this little electrostatic field meter. That's what we can use to measure the fields. And the power supply can output up to 125 kV. But don't forget, this is running like a Van de Graaff. So on a Van de Graaff, you put on 10 kV onto the roller and it rolls the film up. And it sticks it on one side and rolls it up, and then it builds up on the other side, and you get up to 1,000,000 on the other side. So the voltage will be limited by the humidity of the room. And it's going to be more of a field effect. It's not like voltage is coming out of one wire or something like that. This is a high potential static field that's rotating around in a leaky dielectric. So it's kind of a unique experiment. That's kind of what we believe was happening at that 3M plant. I could barely even get the whole device in my camera. I got to like hold it all the way at the edge of the room. This thing is big enough we can walk through it without even bending. We'll be giving you guys an update in a little bit.
Awesome. Well, thank you, Mark. Drew, did you want to do an update now? You're still muted. There we go.
There we go. There was no unmute. Mark, I'm very familiar with that 3M artificial wall thing that you're talking about. And although I don't know if Dr. Charles would agree with me, I believe what you're seeing is a version of our DIV thrust, which is you pass a diverging electrostatic field through any material, and it induces a force in that material.
This is not a force in the material. This is a force in the area around the material, like feet away from the material.
Yeah, I know, but I believe that what you're actually seeing is a real world example of our diverging electrostatic field force, which it isn't doing anything to the area outside because it needs a high enough mass. So the air really doesn't have that much of a force on it. But as the material passes through the diverging electrostatic field, it actually induces a drive inside the material itself. It's part of our research, and it's sort of what I was going to show tonight.
Interesting. So
that
jives pretty well.
Yeah, it's amazing because it's 1,600 times the thrust of the asymmetrical electrostatic pressure force. The divergent force is 1,600 minimum, 1,600x and it's amazing. So kudos, man. Try not to kill yourself because you can build up 1,000,000 volts on that Kapton real easy.
Oh yeah, we're well aware of that. But
Yeah.
not in this humid environment that we have here. But we could build up a pretty dangerous field. We have a defibrillator here.
No, you could put 1,000,000 volts on that Kapton even in that humidity.
Yeah, I believe you.
Yeah. Don't just treat that, and there's no way to get it off that Kapton. You have to bleed it off. So
Yeah,
you
we
can't
got
just ground that
rollers.
plastic.
So there's rollers over here where the high voltage is going to be applied to. So we got ground on one side and high voltage on the other. I don't know if 1,000,000 could hang on 5 mil of Kapton, but you could definitely get up there in the 100 kV range.
Well, it's on the surface, so
Yes, surface.
And this is just a thought. The field means everything. So if you are putting that, actually, I'm very excited about this, Mark. So give me a holler when you get done after this mess tonight.
Okay.
But what I'm thinking about is the direction of the fields. Right now, you've got all your. Are you putting the charge on the inside plastic or the outside plastic?
The outside of the plastic.
You're putting it on the outside of the plastic?
Yep.
Okay, that means that the divergent field will be going perpendicular to the surface of the plastic. And I guess it would be passing through the Kapton also, so it might be going on the inside. That's interesting. We have a much more structured use of the field to generate thrust. You just sort of have a shotgun approach because you've got fields spilling out in all directions outwards. Okay, anyhow, just very exciting. Thank you.
Yeah, if I may just break in for a moment here and talk about that. So I built a tiny version of that thing. It's got like a 7-inch wide cross section square area with a up to 4-inch wide belt. And what he's got there is a 1/4 scale as far as the opening area device versus the entire original structure, which was, I think, a 22 or so foot wide belt that went up 20 foot off the ground, 20 foot over, and 20 foot back down, or something around those lines. But you roughly end up with 3 sides of a square. The difference is we don't have a ground plane currently being applied to that experiment, so there isn't the extra capacitance between the 3 sides of the inside facing section of the belt and the ground plane, because you have the return path for this one single belt. And so we may have to shield that off and generate the capacitance required in order for the field lines to connect to whatever happens to be in that space between the two. But a few considerations. It's a bit different in a couple of ways from the original experiment, but it at least has the key factors that are required, and we've stepped up the size, by many orders of magnitude from the tiny experiments that I did. So it should be good enough.
Jeremiah, do you have demos that you can share? Do you have any videos or anything like that?
I'm going to get on with my cell phone a little bit later, and I'll set that up on a tripod and show my mini version. It's kind of interesting too what it does to the adhesive that is still present on the surface of the belt, because I just used basically packing tape for my belt for the time being. But it's interesting what the ions do to it, so that's something that I'll also show. But we'll get to that later. I just wanted to share a few things about the voltage considerations and what we're working with.
And so just so you guys know, I had locked the meeting and I unlocked it. So we'll cross our fingers and hope that our exciting spammers do not jump back in. What I'll do is I'll probably end up updating the link for this, and then I'll just send that back out in email, and we'll just pray to God that we don't have spammers in our lists. I don't chalk this kind of stuff up to conspiracy. I chalk it up to kids having a little bit too much fun, but
well, it's public links, right? So the link was posted publicly, and then that link and the entire associated video was taken down and ripped offline. So that was all pulled and removed now, and it shouldn't be out there anymore. So unless it's still getting shared by person-to-person links, we should pretty well be stabilized for people coming in, and I would still want to filter anybody else that's coming in. But
Yeah, I know.
yeah.
I know.
I
And
mean,
you know,
if I was you, I would lock it. I don't know if there's any way to put people in the back room until you approve them, or just have it, to the point where the host has to approve their entry, but set that back up at least.
so the challenge that we have is our mailing list is up to like 3,000 people, which is really cool. But then the downside is like folks sign up and you can't really tell. You know what I mean? So like I'll update the link in email, but like my worry is that if we have folks who are in that list, then I just wouldn't know. So
Well, right, and today was just one more example of probably what's going on with the drone situation, and now with this new release of potentially the concept that they could be anti-gravity in nature, right? So that news article was posted out there, and I think a lot of people probably here today have at least come across it or been sent it by a friend, because that's a hot topic.
oh,
And
I didn't see that one. Drones, what could be anti? Let me
Yeah,
look
there's a
that up.
connection between gravity research and the Cybertruck bombing as of like the last couple of days.
Yeah, and so the Alternative Propulsion Engineering Conference is definitely going to attract more attention than it normally would because of the search terms and its relationship to the anti-gravity concept and this drone thing. And so we have people coming in, unfortunately, right now that would normally not be looking at this stuff, that are not dedicated people or researchers. They just kind of are being pulled in by the algorithms, and they want to have a little fun with it. Unfortunately, they also want to cause destruction. So I guess that's their choice.
Yeah.
I'm not
it's
going to say it wasn't
frustrating.
funny, but it's absolutely not okay.
It's too
Yeah.
bad because we created this great platform for disclosure, and I hope people use it appropriately.
Guys, we're ready. We're running.
Okay,
So,
Mark,
all
do
right.
you want to?
Well, let's switch over to Mark's full screen. Hey.
Yeah, put me on full screen. I'll show you guys what it's doing over here first. It seems to be, let me shut off the light for a second. Oh, we got the TV on, so. There is some arcing over there. You shut the TV off.
What potential are you charging that to right now?
So right now we're about 10 kV. I'm gonna shut off the TV, shut off the light.
Is the arcing over the corner of the belt, around the edge, or is it through the material?
It's around the corner.
Awesome.
Not through the material.
Very good.
Okay, so basically you've got a source of high voltage and a ground underneath the Kapton?
High voltage underneath, ground above.
Okay, whatever. So yeah, so you've got one on, so you're putting charge on the outside of the plastic.
Mark, I got to give you points for you are one hell of a builder, my
Outside the
friend.
plastic, that's correct.
The fact that it's made out of connects,
You can start
I
putting
mean,
up in
that's
balls.
definitely something worth noting.
Yeah.
It does look cool,
Very
I ain't
cool.
gonna lie.
I'm curious, does the arcing mean that
Got a ball going through.
does that mean that the static is being neutralized? Does any potential force?
Yeah, it shouldn't be arcing over. Ideally, you turn it down to a voltage that was just beneath the arc over potential.
Yeah, Drew talks about how arcing is the bane of his existence in his experiments.
It's the bane of almost all high voltage experiments. Honestly, if you're trying to look for fuel profiles and control things very precisely, arcing is horrible.
So I have a question about the mechanism here. Is this attempting to modify the local dielectric constant basically in order to change the value of C?
Oh, I could feel the field.
Even from where you're standing, yeah?
Yeah, you can feel it. You can feel it from feet away. I power this thing up.
You need to put the calibration neutralizing plate on that thing to set it to 0 before you start to make your measurement.
Yeah, or walk to a whole different room.
Yeah, different room, grounded out.
Yeah, there's a strong buildup of field right here.
Well, that does follow along with what Ben Dirk was saying. I mean, Ben Dirk is here today, so he already has all of this in the new electrodynamics PDF that he's posted free and available
I'm
online.
feeling some
so-
weird tingly feeling in my hand when I get close.
Yes, that's exactly what you want to see.
Okay.
Okay, I got that too in my experiments. Very good.
But would that be normal static?
I kind
No.
of
Yeah,
feeling like a
that's
corporal
probably
tunnel
static
kind of feeling in
electricity.
my hand when I get close to it.
Are you
It's
serious?
not normal static. It's like a numbness.
Yeah. Interesting.
It feels very different. You don't hear any crackling or see any corona or anything going to your hand that causes this type of sensation to occur.
Yeah, I mean, with
I
normal,
gotta tell you guys, I think it's a large scale version of the divergent field force.
with
This is
so
really exciting.
normal static, you're gonna have your hair will stand up, and I've felt that. I've never felt a numbness though that I can remember.
Yeah, it's a very different sensation, and you notice it with this complex electric field.
Interesting.
Even the small version did it, but it wouldn't do it with the humidity low and with the temperature low. So
Do you think? I mean, so nerve conduction is based on ion transfer, right? Do you think that it could be interfering with the ion transfer?
I think the mechanism of interference is actually much more complex than that.
Could be.
And I would poke at the concept of space-time modification. But I don't want to get into that because half the people here are going to have issues with what I say about it. So I'll just keep that
Would there
one.
be a way to use like a tiny, can you get an atomic clock and put that in the field and then have a different one somewhere else?
No, but you could maybe fill up a container, a clear glass container with water and put in some micro balloons or something that could show you if there's a current in the or a vortex or something.
Right. If you wanted to take the QED approach, you could say that the superimposed electric field that is being induced from charges carried on the surface of the belt are somehow polarizing the quantum vacuum, and as a result, the virtual particles that are partially separating can somehow deposit their momentum on whatever happens to be within that space. So it would be similar to your device, Drew, in that way. But
yeah,
similar to a lot of other devices that came before it as well, including T.T. Brown's work and many others. So that's kind of what I'm looking at with this system, and why I've tried to make my own tiny version of it, and why he's building the giant version of it, because we thought mine was, well, it just wasn't big enough.
Mark, this is impressive. This is impressive.
So let me give a little debrief of what exactly happened over here. What you were seeing was a discharge between the two rollers, the roller on the bottom being negative high voltage, roller on top being ground. And the roller on top, at some point it got stuck. Kapton still has a bit of a charge on it. There was arcing going around the edges. Now, the rollers are not the same diameter as the Kapton. You got about a half an inch on either side. Actually, it's a little bit closer, a little bit more on this side than on that side. I'm thinking for a future version, I may move either the high voltage or the ground side, or might move it over one notch, just so that they're not too, super close to each other, and try it that way, or just reverse polarity first before making any of those changes. But yeah, that's what's happening with this setup right now. This is ground. The bottom one was high voltage. When I originally got it running, while everything was running properly, and this roller eventually did get stuck in this position. It need to loosen it up and get it back down there. But I was able to feel a pretty strong field, strong enough to give me like a shaking in my hand when I got close to it. We didn't notice too much of a difference with the balls going in. But I don't think our fields got strong enough in this initial test. Any suggestions? Jeremiah, you got any suggestions?
If you could take that static meter and go ground it out in the other room and then hold it 1 to 2 inches away from the belt as it's going, and try to identify a couple of different points around the belt and get a ballpark field strength using that might help you identify better numbers for the tingles you're feeling.
Yeah, they were about 12 kV. I think that's what the meter said. I didn't get really close because I started to feel a tingle in my hand. I didn't want to get any closer to that. But
You got up to, it was looking at like 4 kV.
yeah, that's when you tried it. That's after the roller got stuck. The numbers dropped
Yeah.
down.
I would
Similar
recommend
sensation from
if
this
you-
machine here too.
I would recommend on with the meter, have something where you have a physical structure where you have it attached to, say, a piece of wood, so that in case your hand starts trembling, that you don't drop it.
Oh, okay, yeah, maybe I can make something out of Connects actually.
Well, there's
If-
an
if-
interesting phenomena here too that happens, and I want to point it out because, hey, Tim, if you want to switch over from Mark's screen to my screen, I'll show this off and talk about what Mark was experiencing physically.
Yeah. Hold on. There we go.
Yeah, there we go. So yeah, so this is my little machine that we started out with, and this was the original idea when we tested it. They're just the field area versus the belt size wasn't significant enough. We couldn't get enough charge to stick to the belt, even with a low plasma discharge on the surface. It just the field wasn't strong enough. But there was one thing. Well, there was two things that we noticed. The first thing is the humidity that you can saturate into the air is extremely temperature dependent. So if you raise the temperature, you can get a very large amount of humidity active in the air without having it anywhere near the condensation point. So that means it doesn't stick or condense to the surface of the belt, but it's a very active role player in the coupling coefficient between, in this case, you can see that tape roller belt, and whatever happens to be sitting inside here. So if something comes in that has a neutral electric charge, and there happens to be 100 kV on the inside of this thing relative to that neutral object, there's going to be an induced charge motion, and so there's going to be a net force on this object if there's any kind of ground point. But in the original machine, right, so the whole bottom layer here, this is a ground plane, and the belt only came off the side. It came in from the side, went up over the top, then around and back down. But there was this ground plane here, so that means that every single point along these belt surfaces over to this ground plane are all forming this dipole moment. And so you have sort of this center area where your field is electrically the strongest because of the motion of the belt relative to the stationary position of the observer or whatever happens to be in there, whether it's a fly or a bird or a person. By the way, the reason I mentioned a fly or a bird is because both of those things are what Swanson reported the employees saying visibly seen trapped in the electric field of this weird 3M phenomenon. And they were making the exact same kind of tape that we got on here right now. So they were making basically like this packing tape and office tape. And so this material should be pretty much similar. It's just not large enough, and that's why Mark upgraded to go 1/4 scale instead of my tiny little version there. But that's the basic overview anyways of what we're dealing with. And right now it's a matter of getting the charges trapped in the belt. But when we went from 20% humidity to 80% humidity, the difference in the sensation went from you have to be within 1/4 inch of the belt to feel it, up to, and that's at 20% humidity, up to at 80% humidity, same temperature, same pressure. You can be anywhere within basically about 1 foot of it and you can feel it. So if the humidity is not present, you will not get this effect. For whatever reason, just something to consider if anybody is trying to replicate.
The thing that impresses me, just as kind of a third-party bystander, is like this story has been out there for decades, and so many people have wondered about it. I remember hearing about this like 20-something years ago, and it's one of those stories that sticks in your head, and you're just like, I wonder, what if? What could be going on there? And
back in the old coffee days and the Tesla Tech days, Bill Beatty posted up on the AMA-SCI website this strange story about the 3M electrostatic wall, and he also posted up about something called the gravity capacitor, which probably got some people in this room today involved in this in the initial place. But those two things, they were both phenomena that were reported, right? So Swanson didn't, and he didn't intend to report about this crazy phenomena that he observed. He was just an electrostatic suppression engineer. He was an ESD specialist, and he was there at the 3M plant on that day to deal with an issue that the employees had called in and told management saying, we have a problem. We can't go near this machine when it's running during, the certain part of the day, and we need somebody to come in and fix this problem, otherwise we can't work. Because we get stuck in this weird field and we feel strange and it makes us sick, or we feel tingling sensations in our appendages, exactly like what Mark just talked about right now. You feel these tingling sensations and they're not like at all a normal electrostatic effect. And that's because individual ions are actually being formed above the surface of your skin, and then they're hitting your skin. So there's no other charge that's free to move prior to just above the surface of your skin. So only you experience it. And if you put a probe there, you'll also get that same measurement on the probe. But that whole thing, that being an identical report, and in combination with the fact that I also know a guy who went there 1 week after, and I won't say his name because he hasn't given me permission to talk about his report on that, but he went there 1 week after David did and reported on, or told me about what he had seen. And I guess they were all connected at that time. So David only went to the ESD conference and talked about the 3M invisible wall phenomena as an educational thing for other ESD engineers to try and prevent electrostatic problems, not because it was electrogravitic or because it's screwed with physics or any of the stuff that we're interested in. But he got bombarded with questions, and so, no surprise, the fact that I have 2 different verifications for it and that we've already seen these kinds of effects gives us a lot of promise that these machines can, and probably will, if we can get it just right, do what the original machine did.
I have a question. It might be a consideration. Like, how long was the device in the 3M plant running before this was observed? Like, did it ever stop? Was it days that it had to be going before the field built up to
No,
that?
okay, so the field starts to build up really, really quickly. What will happen is they have to manually unspool the roll. So they start out with a giant roll of polypropylene film that's 20, like I said, I think it's 22 foot wide, but I don't remember the exact dimension. And it's, it's got quite a long length to unspool. So what they're going to do is run it through a slicer, but because the slicer is on the opposite side of the doorway that fork trucks and employees walk through, it goes up and over and around, so there's this big old kind of archway that it has to go around. And so they have to manually grab that belt with clamps, pull it up over the rollers, bring it back around the other side, and then mount it to the slicer, and then start the slicing operation once it's all set up, right? And so while it's unspooling, you have a full belt of material, and you have one side of that belt of material that's coming off and peeling off. And as these two sides, they roll away from each other, it's exactly the same thing as a Van de Graaff generator. You get these huge triboelectric charges. And those triboelectric charges start out at lower voltage, just a few hundreds of volts. And as they peel away, they reach thousands of volts. And eventually, as they reach a far enough distance, they reach millions of volts. In the same way that a Van de Graaff generator felt by mechanical force and charge separation of charges stuck to the surface of the belt can reach incredibly high potentials. So at some point, they were strong enough to induce a capacitive field to the object that's placed in the center or walking through the center between that and the ground plane. Does that all make sense?
Yeah, that makes sense. A little more context.
Any other questions?
No, Jeremiah, thank you. And Mark, thank you. Again, absolutely amazing.
Any recommendations for the next test?
Yeah, Mark, I'll get with you.
I had a question.
I'd love to see some changes.
Maybe you guys can hear me.
Yeah.
Okay. Yeah, my question, Mark, is if there's any chance that you can do something with a weight experiment, and I wouldn't use a digital scale. I would use something that's with the spring, just to see if like anything happens in the field. And you probably want to have something, non-metallic but heavy. So just curious.
That's what we were doing with the ball dispenser. Pretty much, we got 3 different types of balls going down a ramp, and it's calibrated and steady so that every single time the ball would land in the same spot, same type of ball. And as it's going through the field, we'll see if there's any difference. That's kind of what we're trying to do here.
Yeah, and guys, at some point, sorry, this is kind of an aside. I want to circle back to John. John, I didn't mean to leave you hanging, my friend. I've got your presentation loaded myself, so I can.
So one comment real quick. I'll think about that. That's a good idea, but that may be different than a balanced force. So I'll think about that though. Thank you.
Awesome.
One more thing, on either of these experiments, my mind wonders, what if you set up the same thing in addition to the one going vertically, you set up another belt that was horizontally oriented as well, so that you had all 3 dimensions covered, and try to measure forces in the center.
Oh my God!
You would still have 3 dimensions that weren't covered, Brendo. 3 dimensions that still need to be counteracted against, because you'd have to have a belt going clockwise and a belt going counterclockwise for every single axis.
I don't even know if I have enough room in this room for that. Like that.
Maybe on Jeremiah's tiny version, you could do that.
Yeah,
I don't think any of us want to build that. I mean, these are difficult.
We had a lot of fun building this out of Codex.
That might be something I have to do someday.
I mean, if there was something to it, I'm sure we could find a more clever way of doing it than running a belt across rollers, like a fluid through a tube that was charged, or some kind of solid rotor, or something else like that. But there's got to be a better way. I mean, Brandenburg went from taking the concept of this whole new electrodynamics and using motional parts with a rotor and a stator to a completely solid state version that just simply used the relativistic difference in velocity of charge flow to produce these forces. And so there are ways to take all of this, I think, and do it solid state. But right now we're just trying with the basic original experiment as close to it as we can get with something that's feasible.
Okay.
Yeah, guys. Mark, can you set us up a meeting to talk about this? I got to show you all some stuff that I can't put out here.
And then, Drew,
Yeah,
did you want to do your update now?
Yeah, I think I'm ready.
Okay, so let me spotlight you then. Oops, sorry, I just muted you. I'm an idiot. Okay. I meant that metaphorically. I'm an idiot metaphorically.
Okay. Well, mine is nowhere near as exciting as the stuff Mark was doing, which was incredible, by the way. So I am going to try and share my screen. I have no idea. Y'all seeing what looks like a big vacuum chamber in a shop?
Yes.
Yep.
Okay, excellent. I'm going to take a shot at just running the video because it's too cold out there. So I did it on video a few minutes ago. And there's audio. I have no idea if the audio is going to play. So let me know if you're hearing audio. And if not, I'll narrate it myself. Can y'all hear anything?
No, I don't.
No audio.
No audio? Okay. So that's what I was thinking. So this is the large vacuum chamber, which has been eating my life for the last 2 months. It's 78 inches long, 68 inches in diameter. And what you're seeing right there, what looks like a crappy weld job, is 6 hours worth of professional class welding to integrate that flange with those 2 smaller half nipples on it into the larger steel structure. This is where the giant 16-inch diff pumps came off and got thrown in the garbage years ago. And then there's a whole bunch of smaller interfaces that all get welded on. So I'm trying to bring this chamber, which is probably 50 or 60 years old, maybe older, somewhere into the current chamber time, by putting on quick flange interfaces and conflat interfaces. So again, this chamber will be available to friends and family, true believers only. Just don't send me an experiment. You have to come with your experiment, and we will put her in the chamber with a little forewarning. So this will be able to do 10 to the -6, mid 10 to the -6s, and we'll be able to have high voltage pass-throughs, full data communication. But I just want to let you know this is open to the gang on an as available basis. This is my main system. I've been messing around getting set up because I'm having a lot of problems with my high vacuum sensors. And just kind of reconfigured all kinds of stuff all over the place today before where the welders showed up. And this is the electronics package that we're getting ready to completely upgrade. That's all an integrated high voltage positive and negative system, digital switches, which go down to about 30 nanosecond, which I'm finding some very interesting things about that. Super high speed pulsing. That's one of the test articles in the chamber. So the idea is to simply replicate all the abilities of the small chamber in the monster chamber. And that way we can have kind of testing in small and testing in large. And that's pretty much what my life has been for the last month or two. So kind of a close-up of the misery that is welding is something like this. It's one of the original team members. He only shows up when we have to do, world-class welding problems. Welding on a big thing is no joke, especially in the field, and dissimilar metals, and that is absolutely no joke to be able to do something like that. This is what the chamber looked like again, a week ago. It was horribly painted with 12 different coats of paint. It all got kind of ground down to a base coat of some kind of green, I don't know, zinc chromate, maybe, who knows, probably lead based. Anyhow, that's what Drew in sunny Florida's been up to. Now I'm going to see if I can't figure out how to shut down. I don't even know where it went. Oh, stop share. There we go.
Awesome.
Questions?
Drew, thank you, man. Thank you. Okay, and so if it's cool, guys, I want to go to John, but first maybe I should preface this. Let me do a really quick screen share. So I don't know, maybe it's just our community, but like everybody else goes on vacation over the holidays, and then we get busy in work, right? So I'm going to share this one really quick. I haven't hit publish on this yet. So I have been busy. One of my projects over Christmas was I started taking some of the interviews that were most interesting and writing those up on Medium. And so what I've been doing here, it works fairly well, is I'm using a tool called exemplary.ai to transcribe these. And then I'm using ChatGPT to clean them up, basically to fix the grammar. And then you have to go in, it's not perfect, but you have to go in and do editing after that. And so the reason I'm showing you this one was, this is an article on Martian Panspermia based on an interview I did with Dr. Stephen Benner. He is one of the top microbiologists in the world. He actually invented 2 new types of DNA. I think it was like 6 base pair and 12 base pair DNA. And he was invited to speak at the Mars Society, the 25th annual Mars Society convention, about the origins of life on Mars. And so his thing was, he was saying that basically boron in the soil would make Martian, like it would make RNA stabilized. And so he was talking about that. And then the other thing that he got into, and he makes a really good case for it, was the idea that asteroid impacts, right, which used to happen far more frequently all over the solar system. These kick up rocks from almost all of the planets except for Jupiter and Saturn. And so, these asteroids would hit Mars and could potentially bring life to Earth, and vice versa. And I thought that was really interesting as well. We know that life is here on Earth. So he was saying that asteroid impacts over the last few 100 million years, right? Like the one that wiped out the dinosaurs, could have kicked rocks with life into space, and those would have been drifting. And so it's entirely possible, like Elon Musk is talking about colonizing Mars, it's entirely possible that we already colonized Mars with microbes and bacteria and things like that, you know? Um, and he said, you know, it might even go beyond that. If it manages to escape the solar system, who knows? Who knows how far it could go? So that was a really interesting idea. And what got me was John called me this morning and he has new information about panspermia. Here, I'll ask John to unmute there. And so John, let me bring your paper up. So I'll thumb through it.
Okay.
But yeah, so I would say just run through it, and you have completely new, different information than I did, but it seems like it dovetails together and it's happening at the same time. So,
thank you very much, Tim. Can you hear me?
yeah.
Okay, great. And once again, we'll try this again. A pleasure and honor to be addressing you all and to be addressing APEC. I'll run through this fairly straightforwardly. Basically, the new information is that in Australia, they've now found what are called stromatolites. They're in modern times, they're a mineralization deposit around green, blue-green algae. And this is one of the earliest things to live on Earth. And these things are now, they've established they're 3.5 billion years old. And I'll show you why this is so significant. Next thing, please. Okay, to cross the Rubicon means to make an irrevocable decision or to reach a point of no turning back. You basically, you make a decision, you cross the river, and you're not going back. You burned your bridge, and it's my thesis that the human race must decide, based on strong evidence, that it is not alone. Scientific discoveries are ultimately a decision, and that other life exists in the stars around us. Next, please. Okay, I'll talk about, whoops, go back, please. Okay, I'll talk about panspermia is now confirmed by a discovery of fossil life signs in 3.48 billion year old Australian rock. The Earth is only 4.5 billion years old. We'll be talking about confirmation of this from CI meteorites, which are loaded with microfossils and organics, and they are probably from Mars, and this is very consistent with panspermia. So we have panspermia has been, strong evidence for panspermia has been found in Australia, and the work from Mars is consistent with that in terms of organic matter found in old lake bed sediments on Mars. Strong signs of methane and oxygen emissions found on Mars indicating microbial activity at present. So we had Mars past life and Mars present life. And then vivid and changeable color areas on Jupiter suggesting aeroplankton, which is a phenomenon they find on Earth in the clouds. And this is consistent also with life. So then I'll summarize and conclude. Next, please. Okay, the first billion years, roughly, of the Earth's life, or rather the Earth's existence, was what was called the Hadean epoch, or hellish epoch, from Hades in the Greek. So about 4.5 to 3.5 billion years ago, this place was full of seas of molten lava, volcanoes constantly erupting, constant impacts. Of course, there was the big impact that apparently formed the moon. I find that theory to be the best theory available for how the moon formed. And so there was no liquid water at that time. Next. Now, these features called stromatolites are found in the very old exposed Pilbara Craton body of rock in Australia. It's in the Australian outback, used to be part of an ocean or a lake bed. And so these fossil remains of algae colonies are 4.5 billion years old. So the Hadean era had basically only barely ended when these things were formed with liquid water. So algae colonies existed on Earth as soon as the surface cooled enough for liquid water, apparently. Spontaneous generation, which is the old theory, the present theory, in fact, of life from the primordial soup on the early Earth, sloshing around back and forth, and then suddenly out of this comes living cells with cell walls, nuclei, RNA, DNA, enzymes, all of that stuff. That's no longer viable. I mean, there isn't time to develop that sort of stuff by random chance. You'd have to say, oh, life came about miraculously on Earth. It's like somebody being born and quoting Shakespeare is these blue-green algae formations this close to the Hadean era where there was no liquid water. So the simplest explanation is that life is seeded elsewhere in the cosmos, panspermia. Now, Earth is 4.5 billion years old. The universe is 13 billion years old. And so life began. What this does, it doesn't explain how life began in the universe. What it says is that you basically evaded the question of the details of how life originated. You're basically just saying it originated in some galaxy a long time ago, far, far away. So you basically said, we don't really care about the process that started the life. The universe is so much older than the Earth. It started someplace and it spread here. And next, please. Okay, stromatolites are formed by blue-green algae. The cyanobacteria, also called cyanobacteria, meaning blue-green bacteria, are photosynthetic, possessing DNA, RNA, enzymes, chlorophyll. These are very ancient, yet they're very sophisticated. They're very highly organized. And so the first billion years of Earth was Hadean and mostly lava and large impacts, no liquid water. And we can't, it's almost impossible to believe that you could form sophisticated life in this brief period of liquid water that existed between the Hadean era of liquid lava oceans to liquid water oceans. And so this leaves about only 1/2 billion years for cyanobacteria to evolve from primordial soup. Now, if that actually happened, that means life is very likely. And then that means it's everywhere, because it means that life is a very likely event. That means that there's life in the stars because it started on Earth so quickly. Now, if life is unlikely, which is the present understanding, is that life is very complicated and almost impossible to arrive at by random chance, in a primordial soup slopping around, then cyanobacteria came from someplace else, panspermia, from an earlier epoch of the cosmos, a 13 billion year old age, and has spread everywhere. And that is the most likely explanation at this point. Next. Now, these are what stromatolites look like in modern. You can find them on ocean shorelines, especially down in Australia. And they're algae colonies that form minerals around them. And these are modern ones right on the ocean shoreline, and these are fossil ones in the outback on the right. So that's what they look like, and they're 3.5 billion years old. Next. Now, we can make the hypothesis that life on Earth arrived elsewhere from space, either far or near. It doesn't matter where specifically. But it would be likely that it came from outside the solar system because Mars and Jupiter and stuff, they formed at the same time the Earth did. And they formed with similar conditions as the Earth, roughly. So panspermia means life on Mars and Earth. They also got seeded. So if we have strong evidence for panspermia on Earth, then we look for confirmation of this on Mars and Jupiter, two nearby planets, which should have also been seeded from space. And Mars looked a lot different in the past. It had a big ocean. I discovered that, actually, though NASA will not give me credit. And credit I can get from a bank. It's okay. It's a science. And here's Jupiter, of course, which we'll discuss in a little bit. Next. Now, life on Mars, past and present. Ancient meteorites from Mars are full of organic residues, indicating past life, consistent with past life. One of the most famous was ALH 8401. I looked at the data they found, and it looked like they found life on Mars. And I believe they'll eventually get credit for that. And so ALH 8401 was a very ancient rock. It was about 4 billion years old. ETA 7901 is actually a more recent rock, and it also has a bunch of organic residues, meaning whatever organic source of organic matter on Mars there was, it lasted a long time. It lasted most of Mars history. So, next. Now, we have rovers roving around Mars, and here is one it's inside a big crater that used to hold a lake. They've dug down into the rocks, and they found in this old lake bed formation organic matter, complex organic matter. So it's consistent with past biology. So we have now organic matter consistent with past life on Mars. And we found it on Mars. Next. Now, we also know that on Mars, we have two gases that are biologically generated on Earth. One is methane, that's swamp gas. And it turns out that during the coldest parts of the year, there's hardly any methane. But then during the summer, all the way through to the fall on Mars, the amount of methane in the air gets elevated, meaning the bacteria gets warmer and wakes up and starts, what it's doing is breaking down old fossil organic matter and getting energy out of that. And the waste product is methane. And same as on Earth in a swamp. Now, also what happens is at the same time and matching the same pattern, during the summer and autumn on Mars, the oxygen level in the Martian atmosphere goes up. Oxygen is the fourth most abundant molecule in the Martian atmosphere, and it's made by photosynthesis. So you have photosynthetic bacteria. Apparently, its metabolism gets more active during the summer and autumn when it's warmer on Mars, and it starts making more oxygen. So we have something that's making methane, which is a hydrogen-rich gas formed by bacteria that break down organic matter and get energy from that, fossil organic matter. And then we have, that's why we find it methane in coal mines. And then you have oxygen formed by surface bacteria, which is photosynthesis. So both those chemicals are rather unlikely chemicals to be formed on Mars now, but there they are. And this means that Mars not only had past life, it has present life. And that is consistent. These biosignatures are consistent with the panspermia evidence we find on Earth. Next. Now, I happened to discover and published that a certain type of meteorite that was known to have more organic matter than any other type of meteorite, it's got 2% by weight organic matter, and people had reported microfossils in it. They're very ancient. They're roughly like 4 billion years old. They're a watery clay mixed with tar. They're basically old lake bottom from someplace. They originate from a warm, wet place, rich in organic matter, like an old lake bottom that's dried up. Microfossils have been found in them. Richard Hoover, a PhD, who's a NASA scientist until he retired, took the lead in finding that he would split open rock that had never been exposed to air and use scanning electron microscopes. I'll be showing you the pictures. And he found microfossils in them. Now, there's another type of meteorite that's closely related, discovered by the Japanese, called CY. And they are CI meteorites that you basically put in an oven and heated as if they were near a lava flow or something. They were heated, then ejected into space from someplace and reached Mars. So we know the CI and the CY both have identical isotopes. So we know they come from the same place. But that place also not only has just had warm, wet, rich organic matter, but it also had occasionally geothermal heat, like a volcano. And this would heat some of this lake bottom, and before it was ejected into space. And of course, the other lake bottom was just ejected into space by some other impact. So now, people have done now sample returns from 2 asteroids. And these asteroids orbit between Mars and Earth. So they sample Mars space. Now, remember, we have a lot of meteorites from Mars now, close to 1,000 of them. Mars is next to the asteroid belt. It gets hit with asteroids and it blows some of the surface rock on Mars out into space, and it forms a belt of material orbiting the sun in the Mars orbit roughly. And eventually this gets perturbed by the gravity of Mars and even of Jupiter, and ends up on orbits that intersect the Earth's orbit. And so these rocks end up on Earth. So we know there's a cloud of debris in the Mars orbit that ends up being on Earth. These 2 asteroids, Ryugu and Bennu, orbit through that belt of material that's in the Mars orbit. Next. Now, Richard Hoover has gone and split open some of these CI meteorites, and he finds, using scanning electron microscopes, all these fibers and micro fossils and things like that. Quite frankly, guys, these things crawl with fossil life. Now, that's called a CI. There's a different, distinct type of meteorite that's also rich in kind of watery clay. It isn't as rich in organics as the CI. They're called CM meteorites. And they apparently just come from the asteroid belt. People are happy with that because they only had enough water in them to indicate like some melted ice. But anyway, they also have bacteria in them in scanning electron microscopes. And Richard Hoover discovered this and published it. And he basically takes rocks that have never been split open and exposed to air, does that in a vacuum chamber, and then does the scanning electron microscope and finds these bacterial fossils. Remember, guys, all you need to do is find one microfossil. And you've proven that there's life elsewhere in the universe. All it takes is one microfossil. And they've found billions of them in these rocks from outer space. Next. Now, this is what the two asteroids look like. They're both kind of remnants of larger bodies that have been hit by big impacts. That's why they form this kind of shape. They've actually put rocks in vacuum chambers and hit them with hypervelocity pellets, and they form this kind of shape. It's sort of two cones stuck base to base. So here's Ryugu. The Japanese landed on that with a spacecraft, scooped up some rock from its surface, the rocky, powdered soil, and then took off and brought it back to Earth. And then this is the asteroid Bennu on the right. That was a NASA return mission. And both of these asteroids, next slide, please, orbit near Mars. They basically orbit near the Earth, part of their orbit, and then they orbit out by Mars. So if there's there has to be a cloud of debris around Mars, which is the source of the Mars meteorites. So they're orbiting through it. And for every kilogram of Mars rock that is blasted into space, probably 10 kilograms of just pure dust are blasted into space, pulverized rock. And that forms this kind of almost like a belt of Jupiter or something around Mars in its orbit. So these two asteroids actually orbit through that layer, and they're basically like flypaper. They collect the dust, and that coats its surface. And the surfaces are very dark. So now they have samples from both of these asteroids back here on Earth, and they tested them. Next. Now, here we have, again, there's a belt of material around Mars orbit caused by the source for the Mars meteorites we pick up on Earth, but it's also full of dust, fine particles, which end up on these asteroids, and the asteroids orbit through it, Bennu and Ryugu, and they get coated with that material. So they are picking up that from that cloud of debris. That's what's coating their surface. And so that's what we brought back to Earth. Next. Now, how do you tell if something, you're walking along in Antarctica and you find a rock sitting on the ice? How do you know where that rock came from? Did it just come from Earth somehow? Was it blown out of a volcano on Earth, or did it fall from space? And in Antarctica, most of the volcanoes are dormant. So it's more likely that they fell, any rock you find on the ice, you fell out of space. So now you look at oxygen, which is part of all the rocks, and oxygen has three isotopes. It has 18, 17, and 16. And you can ratio, 16 is the most abundant. So you ratio the 16 to 17 ratio and the 18 to 16 ratio. And this gives you a map. And you can map, I'll show you a more elaborate map, but this one just shows where the Mars lava meteorites come from. Also on that line, every rock on Earth and even rocks from the moon fall on what's called the Earth moon fractionation line. So that's how we know that the moon and the Earth were both formed from the same stuff. This idea that the moon was somehow captured from the outer asteroid belt, that's just not supported by this. Vesta is an asteroid out in the asteroid belt, which got hit apparently by some big other asteroid and contributed a family of meteorites to the Earth, which is picked up. And they, as you can see, they're in blue and they lie down there. So the Mars lavas lie on a parallel line to the Earth and moon rocks on this fractionation line. And then also, if you mix water with the rock, if the rock was exposed to water so it gets becomes clay, it follows that dotted line. And it just keeps going. Next. Now, we brought back these rocks and dust from Bennu. Where do they fit on this three isotope plot, so-called? Now remember, oxygen is very important because it's one of the most abundant elements in the universe and it combines with everything. Oxygen is part of everything. The Earth's crust is, despite being rock, is actually about half by weight of oxygen. So we have the Mars lavas, and then we follow that line up that fractionation line, the parallel to terrestrial and lunar fractionation line. And if we follow that parallel line above the Earth moon line, then we get, we run into Ryugu. And if we keep going, we run into Bennu. Bennu is the bright red square. And lying in between those two is the CI meteorites. So the stuff from the outer surface of these two asteroids, which orbit near Mars, is CI. It's powdered CI. And in fact, the Bennu lies right on the boundary between the CY and the CI. The CY being heated CY. The CY being CI material that was apparently heated geothermally. So the source for the CI material and the CY material apparently lies, the only thing that's out there is Mars. So this means the CY and the CI meteorites, which end up in chunks on Earth, They pick them up in Antarctica, especially. They come from Mars. Next. Now, here's a more elaborate plot, and it shows like there's the CM asteroid type meteorites. They lie below the terrestrial fractionation line. You see the circled, I circled Mars in red. That's the Mars lavas. And then if you follow the dotted line up the fractionation line, the Earth fractionation line, it runs right through the sea ice. Now, I discovered this back in 1996 and published it. I got it published in a regular journal. This created a firestorm because everybody realized this meant there was life on Mars, because the CI come from someplace that was alive. They got microfossils in them. They've got organic matter. They look like old lake bottom from someplace. And apparently that lake bottom was on Mars, a warm, wet place in the past. So now we know where the CI come from and the CY too. And of course, if you have something material, the CI, and then you have, you heat it, it turns into CY. And we know that Mars has a lot of volcanic activity. It's got giant volcanoes, and there were a lot of old extinct volcanoes that were smaller on its surface. So we know that there was a lot of geothermal heating on Mars that converted the old lake bottom, dried up lake bottom on Mars into this high temperature form called CY. So now we know where the CI comes from. I told everybody they came from Mars back in 1996, but like I said, this created a firestorm. It was the most cited article, scientific article I've ever written, because everybody was saying something nasty about it. Oh, Brandenburg is a terrible person. I had one person call me up on the phone and scream at me over the phone that what I had done by publishing this article was not science. He says, it's not science. So, and the reason is, once you accept that the CI are from Mars, it means Mars was alive in the past. Now, that was 30 years ago. I think we've advanced now to the point where people can accept it now. So I'll be putting a paper into the Lunar Planetary Science Conference where I talk about this CI being from Mars business again. So, next, please. So the CI and the CY come from Mars, consistent with past life on Mars. And what this is a consistency test. If we find evidence for panspermia on Earth, where we can take all sorts of measurements, we can go down and look at these rocks, take pictures of them, handle them, this and that, take them back to labs, slice and dice them, and they say panspermia, then you'd say the next question will be, well, what about the two nearest planets to us, Mars and Jupiter? They should have life on them too, if Earth has life from panspermia, and apparently they do. At least Mars does. Now, let's talk about Jupiter. Next. Outside the asteroid belt, there is the planet Jupiter. If you want to really realize how the solar system works, the inner surface, the inner planets of the solar system, Mercury, Venus, Earth, Mars, they're small and rocky. Beginning at Jupiter, They're what are called gas giants. They're, if you had a big enough bathtub, they would float. Earth and the other planet, the inner planets would sink in the bathtub. Jupiter, Saturn, Neptune, Uranus, they would float. They're less density than water because they're full of, they're mostly gas. Now, the closest planet to the sun of this group, and by the way, the asteroid belt looks like an area of the solar system. Some people say, oh, an exploded planet or something like that. To me, it just looks like a place where it couldn't, the planet there couldn't figure out, the stuff there couldn't figure out if it wanted to be a small stony planet or a gas giant. So it just didn't form a planet at all. In fact, it got stirred up so much by Jupiter's gravity, it couldn't really form a planet. That's my own thought. But I don't know. I wasn't there. But anyway, so the virtue of Jupiter is that Jupiter is close enough to the sun to get a lot of sunlight to drive a lot of photosynthesis, which is, of course, the main engine of life. It makes its own food, makes oxygen, and then it's eaten by other bugs. So basically, sunlight is the key to this life. So Jupiter is close enough to the sun to get a lot of sunlight, and you would expect life on Jupiter floating around in the clouds, what are called aeroplankton. And aeroplankton is found on Earth. It's near the ground. It's called pollen. We all know about that during hay fever season. But they found bacteria floating almost up into space. Bacterial spores and dust. The Earth is constantly shedding living dust into the solar system. So we would have expected, you would expect the same thing on Jupiter. If panspermia is correct, as you've established in Australia, that's where you made the case, is in Australia. Then you're looking for, does this match the rest of the solar system? Is the rest of the solar system consistent with this? Mars is consistent. Apparently it had life in the past, an ocean and everything, and it still has some kind of life that breathes methane and oxygen. Now, if you go across the asteroid belt, bunch of small, or you can't have really any planets, then you get to Jupiter, where you've got a big planet. Its atmosphere is like 90% hydrogen, and it's got helium, and it's got methane, ammonia, hydrogen sulfide, rotten egg gas, and some other forms of natural gas. And what's interesting is all of those gases I just described are colorless. They don't have any color to them. Next. But this is what Jupiter looks like. It's a riot of colors. It's got a big red spot. It's got white bands. It's got yellow bands. It's got up near the north, you can barely see it in this picture, the clouds are green. What's green? Chlorophyll. What's red? Well, red algae that also is photosynthetic. So you've got a big red spot, you've got orange and white and yellow bands, and what you see to the right is actually a picture of Venus as it would appear to the naked eye if you were in a spaceship approaching Venus. That's what Venus would look like. These pictures they show of Venus with all these swirls and stuff like that, those are taken in ultraviolet, or if they're taken in visible light, they do all sorts of image enhancement to bring out very subtle colors. This is what Jupiter should look like. Completely colorless. This should look like a snowball. I mean, I've looked at Venus through a telescope. You can't see anything except a faintly yellowish light from it. It's got nothing on it. There's no features. There's no clouds. You can't tell. It just looks like a snowball. It looks like a ping pong ball. And that is what Jupiter should look like, unless it was alive. People have said, oh, we should search in the infrared bands for signs of life. You don't need to search in the infrared. All you got to do is look through a telescope with just a human eye. You can tell that Jupiter is a very lively place because of the colors. Think of the autumn colors. Life is colorful. Think of the peacock. Think of, here, I'll show you. Next. Here are brine pools near San Francisco where they let water from the San Francisco Bay into shallow ponds, and they let the air evaporate, the water evaporate. What they're trying to do is harvest salt. This is run by Morton Salt. Now, as the water gets more and more salty, as it evaporates more and more water, and the salt gets more and more concentrated, the brine changes color because there's different types of bacteria that live in the different concentrations of brine. There's green bacteria for lower levels. There's blue bacteria that grows in slightly saltier water. There's brown, of course. That's generally what it looks like when they first let it into the ponds from the bay. Then there's yellow, even saltier. Finally, the most salty, salt-tolerant bacteria that survives when everything else dies because of the salt. By the way, these bacteria are all called halophile, meaning salt-loving bacteria. Why do they live in these ponds? Well, it's too salty for anything else to live. And they do photosynthesis and things like that. So the bright red, that's the saltiest water of all. And that's got a special bacteria in there that can live in 30% salty water. But you can see it's a riot of colors. Every color of the rainbow. And it's just visible to the human eye. And that's what looks like Jupiter. Jupiter doesn't look like a snowball or a ping pong ball. No, it's alive. And because it's alive, it's full of color, because these are the colors of life, living things. Next. Okay. This is apparently the short version of what I sent. I expected a lot more stuff, but that's okay. That's okay. Now, as it turns out, just to summarize, the discovery of very ancient stromatolites, in Australia indicates panspermia. We don't need to argue. We don't need to go to Mars. We don't need to go to Jupiter. We don't need to go to the asteroid belt to argue that. It's really just apparent from the rocks in Australia. because they're full of traces of cyanobacteria, which is, even though it's very ancient, is actually quite sophisticated. It did not arise by spontaneous generation from any primordial soup, especially because it didn't have time to do that. That would have taken billions of years. You basically had blue-green algae in the water forming these stromatolites as soon as there was a liquid ocean. As soon as the water was, low enough temperature so it wasn't boiling all the time, you had this bacteria in it forming these characteristic mineral deposits. So that indicates very early life on Mars, on Earth. And by the way, Mars at this time looked pretty much like Earth. It was getting hit with a lot of asteroids. There were big volcanoes erupting. Later, it formed an ocean. It cooled off and formed an ocean, just like Earth. But conditions on Mars and Earth were pretty much the same at 3.5 billion years ago. So life on Mars had to arrive very quickly too. And the only way you can do that logically is that it fell as spores from space. So the mineral deposits in Australia showing signs of very ancient life, far more ancient than anybody else has found before, indicate panspermia happened because there's no time for life to spontaneously arise out of the primordial soup. There wasn't any primordial soup for most of the first billion years. Then suddenly you've got ocean water and suddenly you've got blue-green algae in it. It's like somebody being born knowing all the works of Shakespeare. It's just... So now, we can make the case for panspermia based just on Earth rock. Now, if you say, well, if that's true, then we should find life, past life, and maybe even present life on Mars and Jupiter, because they both get a lot of sunlight like the Earth. There's plenty of energy for life to run, and warm temperatures. So what you do is you look at the CI and CY meteorites, which apparently come from Mars. They have lots of microfossils in them, and they're rich in organics. So that is consistent with panspermia. So you discover panspermia on Earth, and Mars is consistent with that. Then you go to Jupiter. The clouds have vivid colors, consistent with aeroplankton of various species. That also is consistent then with panspermia. So evidence of life on Mars and Jupiter, past and present, is consistent with panspermia evidence from Earth. Life comes from the stars and did not originate on Earth. You ask me, where did the life originate? That's not my problem. It isn't. It fell from space as spores. As soon as Earth, Mars, and Jupiter were habitable for bacteria, the spores from space landed there and they were fruitful and multiplied. So life comes from the stars, did not originate in the Earth. You say, well, where did it originate? And I say, that's a philosophical problem at this point. It originated sometime in the 13 billion years that preceded, the 10 billion years that preceded the foundation of the Earth, Mars, and the whole solar system. Life somehow originated there in a galaxy far, far away a long time ago. There. How's about that for an answer? It's a philosophical question. This idea that life suddenly spontaneously arose on Earth or even on Mars from some slopping of around of a bunch of primordial sloop for a couple billion years, that's a tale for little children to listen to now. That is completely not viable. Life began too early on Earth and apparently on Mars for that to be possible. It came from someplace else. The bottom line is we are not alone in the universe. Deal with it.
John, thank
Not
you.
only that, that means we have to build propulsion to go visit them.
Yeah. So, John, thank you, sir. Thank you. That was awesome.
Oh, thank you so much. I thought you guys would like this. It justifies everything we're trying to do.
And let me see. I see. Yep. Okay.
Why, there's old Jack Sarfatti.
Yeah. In fact, Jack has his hand raised. Let me go to Jack
Brandenburg
next.
doesn't know Jack, and I say, yes, I do know Jack. He's
and
a smart
then
guy, and everyone should listen to him.
And then after Jack goes, if it's okay, Jeremiah Pop had some stuff he wanted to share. Jack, go for it, sir.
Yeah, Jack.
Is audio on? Okay.
There you go. Now you're. Yeah.
I want to comment on what John was saying. It's pretty interesting. And I certainly, I think you gave a really good argument that Jupiter and all these things have life. What I do disagree with you on, however, although you're giving the consensus point of view in which may be correct. I'm not saying it's wrong, but there is a deal. That's not the view I hold. The view I hold is somewhat different. Because I'm saying, because it's time travel, I'm saying, yes, it is panspermia. You have the same idea actually that Fred Hoyle had, and he began to change, that the spores come in, but the point is they come from some earlier civilization, but then that's just infinite regress. Where did the earliest civilization get it? Okay, it's all created. But
An excellent question, Jack. Excellent question.
I have the answer.
Okay.
The answer comes back from the future, and it's all in a self-consistent loop in time, because now I have the physics and we have the observations, all the UFOs, the real ones, not the fake ones, the ones that we're seeing that are the Tic Tacs, the gravity control ones. Those are time machines. They can travel, back and forth through the universe. And so you have to ask not only where they come from, but the most important question is when they come from. When, where, and when. Okay.
In other words, where in space and time?
That's right. This is not a joke. This is not a joke.
I know.
Because I have classified military whistleblower information.
Okay.
That is not just theory, this is reality. Okay. And what we're seeing right now, all these drones, this is contact, this is them, and a lot of these are coming back from the future, hopefully to prevent us from killing ourselves in a nuclear war. That's the best case.
That would be nice. That would be really nice.
Best case scenario. Worst case scenario is War of the Worlds.
Yes.
Okay. So there it is. And can you show, Tim? Can you show that the epic? Let everybody know about
the epic times.
Yeah, that's a big thing.
I think yes. Let me pop that open. Okay. Oops. Okay, and I'll leave the volume off there. And I see that you were on the front page, sir.
Yeah. Okay. So this is a major thing. Epic Times, they have the same circulation apparently as the Washington Post and the Wall Street Journal, within over 1.5 million. And Kash Patel, Trump's new FBI guy, he's a columnist for them. So this is kind of politically important, and this is all kind of physics, but you guys should look at this when you have a chance. It's very slick. It's kind of like a Nova thing, and it's going to be at least in 2 parts, maybe 3 parts. They came to my place about a week ago. They were here like 4 hours of video, and then I don't know what they're going to show. So there it is. Just want to inform you of that. And just so you know, I've been invited to Trump's inauguration. I'm being flown to Washington.
All right.
And then I'm also going to London. And so okay, I don't want to monopolize the time here, but if anybody has any quick questions, go ahead.
Well, Jack,
I
thank you.
have one question.
And I'll be right back, guys.
Yeah. So,
One
John?
question.
Yeah, what? Go ahead.
Can you relate this as rather than physical time travel is kind of informational time travel, like
No,
the Wheeler-Feynman?
No, it's both.
Both.
What
Okay.
I'm talking about physical material time travel,
Okay.
controlling the curvature of space-time. But if you could control the curvature of space-time with small amounts of energy, the problem has always been the energy, right? The energy barrier. And I happen to know for a fact, okay, I have the general understanding, the formal mathematical understanding of how these things are flying around, but I also have been privy to the classified stuff of a guy I know who actually flew one of these things with anti-gravity. He's a pilot. Well, okay, but the main thing is that all these machines are alive. They're all conscious artificial intelligence. Okay. Okay. And we don't actually fly them. We don't fly them. They allow humans inside as basically passengers. Okay. Okay. And so I have a lot of details on that. And it's all consistent with when I was a kid, I was contacted by the Tic Tac, whatever you want to call it.
Yes.
And I'm not the only one who was contacted, all kinds of people, Hal Puthoff, all these people, everybody who's kind of involved, they've all had contact experiences, including Gary Nolan, and all these guys. So in any case, it's all coming to pass. The disclosure is actually here. I mean, you're seeing these things in the sky, right? You see them all over the world. They're in China even, okay? So, I mean, it couldn't be any more obvious. Did you see the other thing about, the Green Beret who allegedly blew himself up in front of the Trump Hotel in the Tesla truck?
Isn't that strange, though?
You know that he's allegedly was part with David Grush and Louis Elizondo.
Oh boy!
And he's, so there's something really going on there. And
they got a drug that induces you to commit suicide, apparently.
Well, I don't think he did. Okay, now here's the thing. I first thought when I first saw it, I tend to be paranoid and but I thought, okay, this is a Tesla self-driving truck, so you can easily program the truck drive itself.
Okay.
Okay, Larry Lemke is a smart NASA, said that in order for these things to work, you have to have hands on the steering wheel. But that's not true because I see these Waymo Jaguars around my place all the time, and there's nobody in the driver's seat, and they're driving people around in taxi cabs. So I think with much respect to Larry, who's a very smart guy. And by the way, Larry was a witness to a lot of the same classified information that I have. Larry Lemke was with me at the time, so it's not just me talking. I have a witness. He's retired NASA, CIA connected. The highest GS-15 guy. So it looks very suspicious to me because when I look, what's his name? Matthew, I can't pronounce his last name. Anybody remember how to pronounce his last name? Whatever. The guy who
Lewinsky, something like that.
Yeah, whatever. When I read his email to Ryan Sprague, who's a Navy SEAL too, right? It doesn't sound like a suicide note to me, does it to anybody else?
No, it doesn't.
It's like he's trying to get to Mexico, right? And then and he's pro-Trump. Apparently his wife wasn't, but so the whole thing is it smells like murder, he wrote. It's like an Agatha Christie.
Absolutely.
I I read this was on LinkedIn. Someone was speculating, maybe this is too far out there. They thought that this might have just been like a tailgate party that went wrong. They said the stuff that was loaded into the back of the Cybertruck was consistent with someone who was going to go out in the desert and just party. And they thought
Yeah.
maybe something sparked, right? But I guess to add to that, the Cybertruck is almost the worst design. Elon Musk posted about this. It actually contained the fire and the explosion for the most part. And
Right.
so if they were trying to cause damage, this would be the absolute worst thing they could use.
Well, he wasn't trying to cause damage. That's the point. He's pro-Trump.
Yeah.
Pro-Trump.
The thought that what I read was that basically everybody gets, they had that incident a couple of days ago down in New Orleans, right?
Yeah,
And
well,
that
that's different. That's different.
The thought was that the police are so on edge that when the Las Vegas thing happened, they just jumped to conclusions. But
Well, wait, which happened first? I thought didn't New Orleans happen first?
yeah,
New Orleans happened first.
Yeah, and then the Cybertruck was like a day or 2 days later. And
No, it was only a couple hours, I think.
Was it?
A couple hours.
Yeah. Okay.
But I have no confidence in the FBI investigating any of this.
Oh, of course not.
I don't believe anything they say anymore.
Oh yeah. Yeah.
Well, yeah, guys, if it's okay, we have a couple of hands raised. Is it okay if I go to? Okay, Zoltan, go for it, sir.
Thank you. I have multiple questions, sir, if I may. So just to make sure I understood you correctly, so these stromatolites, the fact that they were discovered, does that mean that the RNA-based life is not viable anymore? That's one question. And the other one is, why do we kick out Venus of this story? And my third question, if I leave my email address here, may I get a copy of your slides, sir?
Oh yes, I'll put them up on.
I can upload
research.
them.
Yeah. Tim, if you could upload them so everyone can have access to them, I would appreciate that. And let's see, I didn't quite catch your questions exactly. One of them, you said that the stromatolite life is no longer viable. Oh no, the blue-green algae is doing just fine. It's like the shark, once you got something that nature believes in, if it works, don't fix it.
Yeah, the thing that got me, and I'm not talking about John's work, which I think builds on what Stephen Benner had said. Benner's presentation.
Well, I'd like to talk to Steve Benner.
Yeah, he is. I mean, again, he is like at the top of the pile in terms of microbiologists.
I'm only a rocket scientist, So
well, what intrigued me was he was basically positing the same thing, but like he had talked about, and John, what you're talking about is microbes in the air, which to me is plausible. He had talked about asteroid impacts kicking up dust and rock and dirt. And, he was like, look, these Martian, and during our podcast, he held up a Martian meteorite and he said, during reentry, this did not get hot enough to sterilize the interior. So he's like, if it cracked open or if water seeped in, if there was something there, it could have gotten out. And my takeaway from that is just trying to keep my mind open to this idea that certainly our solar system, probably our entire galaxy, may be filled with life. And if microbial life can get here, it'll evolve, right?
I will just comment, Mars would have formed and cooled off more quickly than the Earth. So they would have had liquid water on the surface of Mars.
Yeah.
And even if you presume panspermia, it means that life became very abundant on Mars and could have spread from Mars much more quickly than it could from any place else. And so I am in much sympathy with Brenner's idea that Earth was basically fertilized from Mars, because that would become the major source of life in the solar system. It would give life plenty of place to transport itself in rock to the Earth. Let's put it that way.
And I think it's difficult, at least for me, it's difficult to visualize in terms of timescales, right? Because one of these rocks might be ejected and it might not make landfall for millions of years. But
Yes.
when you get into the timescales that are actually involved, there's plenty of time for this to happen repeatedly. So it's interesting.
Oh, absolutely. Mars and Earth have been swapping spit for a long time. Let me put it that way.
So let me go to HFK, sir. Henry?
Yes.
Two questions. One, on the CI versus CY, could the CY be cooked during an impact on Mars, and then the heat transformation happening at that point versus getting cooked geologically?
Yes. And I'm sorry, HLK. I don't know. HLK, you are correct. A major source of heating for rock being ejected from Mars to Earth could have been just the asteroid impact itself, or one impact followed closely by another. Mars is next to the asteroid belt. I mean, they drove the rovers around, and what were they finding? Big chunks of iron that, from iron meteorites that had hit Mars from the asteroid belt. So Mars is just getting hammered all the time. And so your point is well taken. You don't even have to presume that lava activity on Mars heated some of this old lake bottom and turned it into CY. It could have been turned into CY almost instantly just by the heat of the explosion that put it out into space.
And since we have bacteria all the way to the edge of space on Earth, given that Mars has 0.38 G, it should be a lot easier for it to shed bacteria from the upper atmosphere on Mars, with the solar wind blowing it deeper into the solar system, toward Jupiter. Now,
your point is well taken. That it would also the Jupiter gravity modulation. Jupiter is such a massive thing that it stirs up anything that's in a stable orbit. Let's say it gets ejected from Mars, and then it's kind of in Mars orbit, co-orbiting with Mars, and then it just gets either perturbed by Mars itself or by the gravity of Jupiter to suddenly end up on an orbit that intersects the Earth. And that's, we know that has to have happened because we have all these Mars meteors. We have far more material for Mars than we have from the moon. And the moon, look how close the moon is to us and how much smaller it is, how lower its escape velocity is. So that tells you something, that the frequency of bombardment on Mars is far in excess of 10 times what it is on the moon, Earth's moon.
And lastly, given that the moons of Jupiter out there and extremophiles will find a way to live.
Yes.
Any signs on the hellhole known as Io of life?
Well, actually, I had in one of the versions I sent, which apparently got lost because of this disruption we had. As it turns out, if you look at the food dyes, standard food coloring, they're all made of hydrogen, carbon, nitrogen, oxygen, sulfur, and sodium. Those are the elements that make up every dye in a package of FDA approved food dyes in the food coloring. And all of those things except sodium are present in the Jovian atmosphere. They have sulfur, rotten egg gas. They have ammonia. They have methane. They have water vapor. They have hydrogen. They have everything floating around in the clouds of Jupiter that they can detect, except sodium, but guess what is spewing out all of this sodium in a belt around
Right.
It's Io. So that's where it gets. So it has everything it needs to make, and all of those food dyes, by the way, are the product of they don't use synthetic food dyes anymore. They use stuff that's biologically derived and purified. But at least that's my understanding. And so you have everything you need to make all this riot of colors on Jupiter, except sodium that's right in the atmosphere, but then it's supplied by Io. So if you look at Jupiter compared to like Saturn or Neptune or Uranus.
I should break it to my APEC group that I'm posting to nature.com on.
Oh, well,
Oh.
Sorry about that. Okay. Yeah, Ross.
I'm just going to say that the reason Jupiter may be so colorful is because it has Io contributing these heavier elements to the bugs. Io is fertilizing the aeroplankton and the clouds. In fact, if you go on the net and look for the formulas for chlorophyll, which is of course green, and then hemoglobin, which is red. The only difference between them is that you've got a bunch of organics, nitrogen, carbon, oxygen, hydrogen together with a magnesium stuck in the middle. A magnesium, which is, found very regularly in lava, like would come from Io. And that's chlorophyll. And then if you yank out the magnesium and put in an iron in there, which is another component of lava that would come from Io, you get hemoglobin, which is bright red. So, Io may be responsible for the colorful palette of colors at Jupiter.
So John, let me go to Brendan because he set his hand up. Let me work.
Yes.
Okay, Brendan, go for it, sir.
Well, hello, folks. Thanks for an awesome presentation, John.
Thank you very much.
Yeah, very, very astute work. And I know you're somewhat of an expert on Mars, so I wanted to inject this piece of information I think is really critical to the discussion on panspermia, which hasn't really made the rounds too much, but it's kind of a major thing. So you talk about, you said yourself you don't know where life came from originally, but we've made strides in recent years. They've found, I put a link in the chat to this IFL Science article. They're talking about a study that found that RNA has been shown to spontaneously generate on the surface of basaltic glass in the presence of running water and sunlight, especially around nickel. So, and it's that, like, these materials are basically everywhere. They're in the meteorites themselves. So these things could be happening on the surface of various planets, in atmospheres, maybe even on meteorites in the journey, if there's like a significant like water, like ice forming there, and then maybe sublimating or melting during transit based on the rotation of the asteroid, which is super cool because it could be kind of an all of the above situation where you have panspermia happening and like abiogenesis as well. We know about, like, through horizontal gene transfer, this is how like bacteria and viruses swap spit basically in the micro world.
Yes.
And that provides novelty to the system. So you could have a situation where there's this constant abiogenesis happening on all the worlds as well as panspermia, and that RNA is cycling up into viruses, into bacteria, and then being absorbed into macrobiotic living things, and then making it into this is kind of like an extra agency for mutation, as well as the cosmic rays that you usually think about.
If I could just respond to that, you
Sure.
raised a very interesting.
All right, this is an emergency broadcast.
What?
Oh, sorry, that was somebody else said that we have a few folks who have their mics on. So here, there we go. Okay, John, go for it,
Okay,
sir.
I'll just say, Brendan, I'm just would like to comment. It is interesting. All of these chemicals are found in nature. You can make them with just running lightning bolt through a mixture of natural gas and methane and you know all of this stuff. But like if you just making RNA on basaltic glass in the presence of nickel, that's great. But that's like you can write emails, but no one has an internet and no one has a computer to read them.
Yeah, but there was a really good article about 25 years ago on iron pyrite, which its natural crystalline structure makes a
Yes.
basically a helix.
Yeah.
And they were doing some cutting edge research back then of putting the raw materials of RNA on the surfaces of iron pyrite while it was forming in a cold salt solution, and they were making something that was indistinguishable from the double helix DNA.
Well, but
It
but
was
the thing
it
is,
was it was random.
what kind of animal would it
Now
make?
you're missing the point. If you have 500 million years to experiment, you try everything.
This is I'm sorry, it's Drew. Drew, God bless you, but I'll just have to say this reminds me of the 500 chimpanzees pounding away at typewriters will eventually produce the works of Shakespeare. Well,
Now, MIT just redid the math. That's not going to happen. But
yeah,
what's to say that life
more than
didn't
the
form
works
on Earth?
a
And
single cell of cyanobacteria is much more complicated than the works of Shakespeare.
Well, but it doesn't start there, right, John? I mean,
Well, sure,
that's,
sure.
yeah.
One of the things I wanted to
give
say,
it enough give it enough time, of course. Well, the joke that was on the Bob Newhart show was that they ran an experiment with 30 chimpanzees pounding away on life, and finally they came up with the phrase "to be or not to be." Google mania, blah blah blah.
John, let me go to Ross. Ross has
there was a second part of that really quick.
I'm sorry.
One of the things that they found with these RNA molecules was that they had a weird tendency to self-assemble and organize themselves into groups, and actually had a miniature natural selection process that they've observed, which is, I'm not saying anything, but it's still pretty cool.
Hey, life, the universe is pregnant with life. I'll tell you a really fascinating experiment I heard at Goddard. Oh, God bless you. Yes, I've had children walk through my sessions too when I was younger. I have three wonderful children, my finest achievements. But there was an experiment they did at Goddard. They created an artificial solar nebula, and it started out really hot. So the first things that formed was this fine dust of magnesium, iron, and silica forming, kind of a lava-like dust. So it's floating around in this chamber as an aerosol. And then as it cooled off, they also had like hydrogen and methane and nitrogen and all these things. And they found that the dust was catalyzing this bunch of organic things to form very complicated organic molecules. And they finally got samples of the dust and they sent it to DuPont. And DuPont said, "Where did you get this stuff? This is the best chemical catalyst we have ever seen." And they said, "Well, we're simulating the early solar." So the universe wants to make life. And the details are probably going to be figured out over a long time. But I would just agree with you, Brendan. The universe wants to make life. If you look at the abundance of elements in the periodic table: hydrogen, nitrogen, carbon, oxygen, then things like sodium, sulfur, magnesium, iron. Those are all the most abundant elements. And that's what makes life. Life is not assembled for platinum and gold and rhodinium and all of this stuff. Maybe on some planets it is, but on the most of the planets, like we're used to, it's just going to be the same old stuff. Yeah. And so anyway, Brendan, your point is very well taken, and I agree with you.
Well, let me go to Ross really quick because he's had his hand up again. I got to.
All right. Yes, Ross.
Ross, go for it, sir.
Oh, I'd actually like real quick to piggyback on what he just said. I actually agree with him that the universe does want to produce life, and not only that, it not only wants to produce life, but furthermore, I think it wants to produce life and actually find itself somehow, like
yes,
I don't know, spiritually or whatever you want to call it, or sentiently or whatever, and it's using us somehow to evolve us and then create transistors to where we then created the microchip to where we zoomed in on the microchip and we
that might go back to what Jack was talking about, but in Jack was talking about a recursive time loop.
Yeah, this has been what happened to me recently. I started researching MOSFET technologies and then FinFETs, then tunnel FETs, and all that stuff in my work on the new the really super duper secret microchip stuff over at the Taiwan, with the brand new ultraviolet, the extreme ultraviolet lithograph machine that's over there, the 200 ones that are over there. We cock blocked the Chinese. They're not allowed to have them. We got them now here in the U.S. over in Arizona. The Biden administration put 3 of them in here just now. So now we have the ability to cut chips at those levels where the Apple phone can now have 134 billion transistors on a single chip.
Wow.
134 billion transistors on a single chip now. 134 billion transistors on a single chip now. 134 billion.
Yeah.
That's new. That's brand new.
How many of these transistors are actually doing something useful most of the time? That's what I want to know.
They're all going to be on the new. They're in the new A9.
I know.
They're going to be in the brand new. They're going to be in the brand new phone next year. That's commercial.
There you go.
134 billion. That's real life. They really did it. They honest to God did. But anyway, so I was researching all this because of that of my work. So trying to figure out a better transistor because they went to 3D transistors. That's how they got so small. And obviously every 2 years they got to double. So the law states, the Moore's law states, you have to double transistors. So obviously in 2 years they have to have 468 billion transistors on the microchip in 2 years. That's the law. That's the Moore's law. So in 2 years, the law states you have to have 458
Moore's
billion
law is an
transistors.
observation. It has nothing to do with reality.
No, it does. No, it does. It does. They always
really
do it.
Doesn't.
They always do
stop
it.
Tomorrow.
No, they don't.
It may
They always do
happen,
it.
but
They've done it since 1960. They've done it for 1960, and every 2 years they do it. Every 2 years, no matter what.
It's
eventually you reach the quantum limit.
No, okay, but they think
atoms.
Yes, but they're not at the limit yet. They're not at the limit. They're
But
going to keep
eventually
pushing
they'll
it.
get there.
Yeah.
Okay, but they still haven't. They haven't yet. They're They're almost there, but they're not yet. No, they're not quite yet. But trust me, they're going to get a trillion. They said this. They said Taiwan said they're going to get a trillion, no matter what, by 2030. That's the law. That's Moore's law. It's called Moore's law. Okay, look it up.
That's not
only
not
called
passed by
Moore's law
not passed by
because
Congress.
it's an
That's
observation.
Moore's
That's
law.
I
a
know.
moron called a law.
I know, but I'm saying
Laws
you've
are
got
constructs
a
of
whole
human
building full
thought.
of people.
They're not
Got
reality.
a whole building full of 22-year-old kids that are obsessed with it, and they work feverishly, and they all have PhDs, and they're obsessed with it. And trust me, every 2 years they get it. They get it right, and they do it no matter what.
Okay,
they die for it no matter what. Okay, so it's gonna happen. So anyway, But so when I was doing the research on this, so why they're because so they can try to figure out more and get more and more. What they're doing now is they're getting a microscope and they're looking deep down at the silicon microchip. And so for purposes of the Mach 1, I was doing research on all this. So Mike Marsden gave me his theory about how it works and everything, and he called his theory called a concise cosmological revelation. That was his theory. It's called the fundamental particle. That's how the universe works. That's how his Mach 1 works. So he's been hinting at this and stuff, and he's recently given me his paper to research. Publish it with me and him, and I'm publishing it in Nature.com on Monday. And so with recent data and stuff, I was able to get electron microscope data from looking at atoms at the work. And so we looked deep at the atom, and we saw what are called Kikuchi lines. And Kikuchi lines were seen they were first seen in 1921 on crystals. And this was 7 years before the invention of the electron microscope. So, and then 7 years later, the electron microscope was invented, and they also saw Kikuchi lines too, with even better accuracy, right? And then even over the century, since 1928, all the way to the 30s, 40s, 50s, 60s, 70s, 80s, 90s, they got better and better microscopes. They keep seeing Kikuchi lines.
What is a Kikuchi? What is a Kikuchi line?
They look like crystal. They look like crystals. Like when you look inside of a crystal, they look like you're looking inside of a crystal, essentially.
Oh, okay.
Yeah.
Okay.
So basically, so that's what they look like. So so the more they look in, the more they keep looking in. So and now they're at the point where they can actually look at the atom, like like you're taking your eyeball, and you're putting your eyeball at the actual atom itself, like deep down at the atom, like you're finally putting your eyeball at the atom itself. They've finally gotten this close to the atom itself, finally, like within this year. So it's finally they're at the 1 nanometer level, which is the atom, the one atom. It's literally one atom, small. And they've looked inside and they see inside of it, and they looked at it from various angles. So they're doing it from like here, multiple angles, and then they're plotting all the data from the multiple angles that they're looking at it, and then so they're mapping this, and they're getting these Kikuchi lines, the full breadth of the Kikuchi lines. And their theory is they always think they're electron bands. Like they always think they're electron bands around the electron, around the atom. That's what the current physicists think they are, but they're not. I'll show you what they are.
Well, Ross, yeah, and I appreciate you sharing that. I do need to move along. I've got hands up, sir. So
okay, got you. I got you. But I'm going to be publishing on Nature.com on Monday, and you can read my work. It's all in there, out there, and the whole paper goes all along and at the end of it, it tells you about the fundamental particle and why and everything, why the universe is laid out this way, and fundamentally why it has to look this way. It's a crystal structure. It's a mirror. Basically, we're living in it's a mirror box. We're living in mirrors. It's a split way X, Y, and Z, 4 different dimensions mirrors.
So let me move along. But thank you again, Ross.
Thank you. Okay.
Thank you.
Okay, let me go to Trevor. Trevor has his hand up. Trevor, thank you for your patience, sir. I know we kept you hanging for a while. Sorry, Trevor, you there?
Yeah, I'm here. Yeah,
Okay.
thanks. No problem. John, that was a great presentation. Thank you.
Thank you. Thank you very much.
I love the idea of panspermia, and I think you made a really great argument for how, like as you say, Mars and Earth trade spit all the time. So like given that, I wonder what your feelings are for like kind of planetary protection. Have we been, because I think like with this problem of like finding like possible molecular evidence, there's always that argument like, oh, we've cross-contaminated. And
yeah.
So like, have we been careful enough with what we've sent to Mars that we know that it's not cross-contamination?
No.
How careful do we have to be, like if we're gonna be sending people there, to be able to prove any of this? Because it's like really hard to disentangle like what evolved where.
Trevor, your point is very well taken. And after they landed the Vikings on Mars, it was so expensive to sterilize them beforehand, and all this stuff. They they just said, well, screw it. We're gonna build this stuff and send it there. And I mean, the last stand of the old guard, I call them the old guard, of that basically cosmo-astrological, astrobiological geocentrism, that this is the only place you find life in the entire universe. And
Yeah.
and what they'll do is they'll find cyanobacteria on Mars, and they'll say, see, we brought it there from Earth.
Well, it's not impossible, right? I mean, it's hard to
no,
tell.
it's not. But in fact, we didn't probably even bring it there. It was probably from, the impact. In fact, we'll find dinosaur bones on Mars from the Chicxulub impact.
Right. Oh yeah, that would be really interesting and not impossible. But if
just the tooth of one Tyrannosaurus Rex on Mars,
that would make a great movie.
It was a great movie.
But if life, like you said Mars like cooled down first, and if life evolved there first.
Yes, it became a cesspool of life,
which is likely because, like, if they say like if life evolved independently on Earth that fast, then it would have also evolved there that fast.
It would have evolved. But you could say, okay, life is a lot more likely than we ever thought possible. It self-assembles itself like it's already been programmed. All the atoms have been programmed to make life as we know it. So then you could say, okay, that's kind of miraculous. Sure, and it happened. Then that means that happened on Mars too,
right?
And on Jupiter. You could turn it around on them and say, oh, life on Earth is miraculous. And they say, well, by the principle of mediocrity, that means miracles have to happen on other planets too. So that means the miracle of life happened on other planets. So the universe is full of life. And you come to the same conclusion simply because the stuff on Earth is so old that not even Mars was a fit place to live when this stuff formed on Earth. And so I just think that you can basically just say the simplest explanation is that the spores landed on Mars. And let's say they found a good home on Mars. They were fruitful and multiplied. Mars became a very lively place. It's next to the asteroid belt. It's getting hammered all the time anyway. So some of that spread to Earth simply because big chunks of rock with lots of bacteria on them are going to be a far better way to deliver stuff to Earth than dust, spores in space. So you can make the point that panspermia and Mars genesis for life in the solar system, or at least genesis of life on Earth, those are not contradictory at all.
No. But how do you think that it affects how we should be pursuing the further exploration?
Oh, we just go to Mars and build septic tanks and I'm sorry,
just do it.
It's like asking, how can we prevent invasions from Mars of strange bacteria? Well, you say, well, we can't because they're already hitting all the time.
Yeah, and actually, if I can interject, that was kind of what Benner was alluding to. He was saying that, we do sterilize probes and we sterilize return samples, right? So that we're trying to minimize cross-contamination. But his point was that the cross-contamination happens all the time anyways.
Right.
And, and so like, this raises other questions. Do we have natural defense mechanisms against bacteria from other worlds? And the human immune system, right?
Oh, the human immune system.
Yeah. So, so basically he was, what my takeaway from what he was saying and from what John was saying also is that the universe, life is everywhere. It's probably hanging on wherever it can. Brendan mentioned in chat a while ago that there are fungi around the vents of the ISS outside. So
there are. Yeah, they've been finding stuff on the outside of the ISS, and they've got there's this, they found bacteria that can survive vacuum, cold, heat, acid, radiation.
And there are also extrasolar comets. This was something Benner had mentioned. He said keep those in mind. So there are comets that travel outside of the solar system. In fact, if I remember correctly, our solar system comes within, it's some kind of a gravitational proximity of another every 20 or 200 million years. He suggested that that might be a time when panspermia might actually cross between solar systems, right? So,
well, yeah, I'll give you an example. When the British, at the end of World War II, the British Army, occupied the northern part of Germany, of what would later became West Germany, and now is just, and the British Army issued orders that there was to be no fraternization between British soldiers and the German girls. And you can imagine how well that was obeyed.
Yeah.
In fact, the British soldiers had a term for getting together with the German girls. All of their young men had been killed. They were all lonely. And here's these big strapping British soldiers. And to spend time with a German girl was called grabbing some frat. In other words, fraternization. So you could say, oh, no, there will be no gambling in the barracks of this army. And of course, then you walk in there and there's all these crap games going on. And so it's like, okay, yeah, we say, oh, we're going to pass all of these regulations about anything that got sent to Mars, got to have all these sterilizations and stuff. And we get there, we find the same bugs, as we find on Earth. And
right.
And like I said, the old guard, the geocentric biogeocentrists will say, see, we've contaminated Mars.
Well, I think,
and I'll just say it contaminated itself.
Right. Well, I think my question though is not like necessarily like from a safety perspective or anything like that, but it is like from the scientific perspective of once we have contaminated it, how do like it just makes it harder to disentangle, like to prove these points.
Yeah.
Your point is a very good thing. These British soldiers, they shouldn't have children with these young German girls who are lonely.
Well, yeah. So let me, if it's okay,
this should be strictly forbidden.
Yeah. Let me go to Rick. Rick has his hand raised. Rick, go for it, sir.
Oh, thank you. Can you hear me?
Yeah.
Okay. Yeah, this one is for Jack Sarfatti, if it's possible. It's I want to continue a conversation that I had as Twin Peaks fan club in a previous show. It's about the time travel, and I want to talk about some moral and history and moral things. So, years ago, I used to have a friend who was a son of a Holocaust survivor and she was in a concentration camp. She hid out. She came over here to the U.S., met his father, and and then they got married. Then I had him, and he and I used to talk about if you knew Hitler before he did the World War II, before he rose up in power,
right,
when he was just
right.
If you knew him and he was a young art student, and should you kill him? Well, if you killed him, like, he would not exist because his mother would never come over here from Czechoslovakia. That's the weird thing about history. So I'm having a hard time understanding about the time travel. If the Russians went back in time, why wouldn't they kill Hitler back when he's an art student? Because they, when he was vulnerable and easily reached, because they spent 27 million lives fighting him. So
there's all sorts of stuff.
I'm not saying it's not possible.
Well, let me have Jack respond, because Jack is
Jack.
Very simple. This has been. Can you hear me?
Yeah. Oh, yeah.
This has been discussed so many times. If you just go on Wikipedia, actually, Eric Davis actually gives. There are two solutions to that problem. One is the Novikov self-consistency principle. If you believe there's only one timeline, okay, and when you go back in time, everything is self-consistent. Now, things happen now because of time travelers going back in the past. So the point in the case of Hitler, you may try to kill him, but you're going to fail.
Ah.
And they've actually done Kip Thorne at Caltech and Igor Novikov. There are many papers on this. You just go Wikipedia and time travel. They discuss all this stuff. This is really elementary, well known for the past 30 years. So the self-consistent loop in time is actually confirmed by quantum mechanical little computer simulations they do. And they show, for example, in the Feynman quantum mechanics, if you try to make a probability amplitude for a paradox, that amplitude turns out to be zero. When you do if you have like a wormhole, yeah. Okay, if you have a wormhole and a billiard ball goes back in time through the wormhole, then tries to come back to its earlier self and prevent it from going through the wormhole, that the actual quantum mechanical calculation for that problem using Feynman's rules turns out to be zero. So that's, that was the big thing that Igor Novikov, who is professor, he's very old, he's still alive in his 90s in Moscow, he came up with that. The second thing, alternative to that, is David Deutsch at Oxford, who the inventor of really quantum computing in a way. Basically many worlds, alternate timelines. And he wrote a paper in 1986 on quantum time travel. You can look at it. It's available online for free. And he shows that, you can go back in time and change the past, but you change the past, you're in an alternate timeline. So like Philip K.
There, I think that's
Yeah.
I'm familiar with that one. I've heard that one.
Let me finish. Yeah, I know you're enthusiastic. Curb your enthusiasm. But it turns out that for any one timeline, for any observer, any individual observer, you cannot really tell the difference between the Igor Novikov interpretation and the Deutsch interpretation. So in a way, they're consistent. Depends on what point of view. If you take what Feynman called the bird's eye, like the God point of view, the whole thing, like God's way of looking at the whole multiverse sort of thing, it looks like what Deutsch is talking about. But if you're actually inside inside a timeline, it's as if you had the Novikov. There are no inconsistencies. In other words, the universe is constructed to be time travel paradox free. And this is pretty much the consensus now that time travel is not a problem. And also we know from the UFO observations, the Louis Elizondo's, the 6 observables, all that stuff, that these machines are time machines. There's no question of it. I mean, it's basically a fact now. It's in terms of, my opinion. I'm sure, there are plenty of my physicist colleagues who, by the way, do not have the military intel that I have. And for them, what I'm saying is a severe ontological shock. But they'll either have to get over it or, or not.
Yeah.
Yeah.
Thank you very much.
Jack, quick question. At Roswell, one of these things crashed, and reportedly it crashed like morning of 4th of July, and nobody knew it had crashed. So the coyotes and the vultures got to the bodies for a couple days, and I think they found one alive or something. But that doesn't sound like sophisticated time travel to me. That sounds like a fuck up.
Yeah, but no, well, okay, but there's something you haven't thought about this very deeply, John, I'm afraid. Okay?
I guess not. Time
travel, just listen. No, you haven't, okay? And the point is that time travel, there are many different time travelers. It's not just one group. And some of these, and the ones that crash, they come from time travel technology in an earlier stage of development, just like just like the biplanes versus an F-35, although the biplane is more stable than the F-35. So
what does any of this have to do with alternate propulsion?
What?
What does any of this babble have to do with
alternate propulsion is space-time travel.
It has nothing to do with what you're babbling about, though.
This has everything. It's not babble. You're an idiot. To an idiot, it looks like babble. You're a schmuck. I'm
Well,
sorry.
I think it's
You
related.
say it's
related to
babble.
my-
You insult.
I don't
you
know you,
insult
and
me.
you obviously don't know me. So
Point of
No,
order.
but you
Point of order.
insult
but
me.
have a great life.
You insult
Guys,
me by saying it's babble.
Yeah, that's yeah.
So what
guys,
expect
if
me to
we
react?
could,
I'm from New York. You don't say
if-
it's babble. I'm casting pearls before swine. All right, yeah. So there
Come
we
on
go.
now.
So,
Okay, everybody calm down. Everybody calm
yeah,
down.
yeah, okay.
Drew,
I'm a nice guy.
Drew, we can't change space-time, which is to make anti-gravity, without changing time at the same time as we change in space.
Exactly. This is by the way, this is all elementary application of Einstein's general theory of relativity. And anybody who really understands the subject, what I'm saying is elementary. This is all based on Roger Penrose's lectures. If you go to Roger Penrose, he talks about how you could picture curvature as the relative tilting of the light cones. And I have that, I've lectured on this. This is elementary stuff. It's not Jack Sarfatti talking. This is like Roger Penrose, Nobel Prize talking. I'm using his concepts. What I have contributed is how to get the technology of this with small amounts of energy. See, everybody
there.
See, that's the problem. That's how to solve the energy problem. Okay, and what I'm saying is we already know that these machines that are flying around right now over New Jersey, they have this technology. We're seeing it in operation.
Yes.
Oh, yeah. Let me go to Jared. Jared has a hand up.
If people don't understand enough basic physics of Einstein, they don't understand it. They see these things flying around, but they don't know how to interpret what they're seeing. Okay, so to guys like me, it's elementary, but we understand exactly what we're seeing.
Yeah. So
But
Jared,
most people do not.
let me go to Jared. Jared, go for it.
Yeah, Jack, you just touched upon something that resonates with me regarding the time travel thing. So one of the TTSA members, when they got the Roswell piece sample finally under some terahertz stimulation, they shot a laser beam right next to it and checked the flight time of that thing, right? The time domain reflection of that stuff. And they observed that the flight time of that beam changed when the sample was under the terahertz stimulation. Now, the best thing that I can understand for this, if it's doing some kind of near field metric manipulation, is it's got bismuth and maybe some metamaterial S qualities going on there. And so maybe it's changing the refractive index, right?
That's correct. But you want to know more? I can tell you more about that. Because I have a friend, I'm speaking from secondhand experience from a friend who actually had the materials. First of all, the material is alive. It's conscious artificial intelligence at the nanoscale level. It's alive. So, for example, a friend of mine who actually had, okay, how many of you have read The Day After Roswell by Colonel Corso? Okay. Roswell talks about the strut. Remember the strut with the hieroglyphs on it? Okay. That's real. And a guy I worked closely with actually had possession of it for about a week back around 1969. So, quite a while ago. He was working for the CIA. And in fact, I could say his name because he died recently. His name was Don Rich. He was a top member of the Bohemian Club, Bohemian Grove. You know the Bohemian Club. Okay.
Yeah.
He was his father. He was about I guess if he's still alive, he would have been about 83 years old right now. His father was Kenneth Arnold's foreman ranch at the Idaho Ranch. When Kenneth Arnold landed in his private airplane on his ranch, Don Rich was about 4 years old, or 5 years old maybe, and was with his dad, remembering when Kenneth Arnold's plane landed, and Kenneth Arnold told the story of the 9 flying saucers. So how's that for synchronicity? Okay, this is real. This is a guy who ran Bohemian Grove. You know what the Bohemian Grove is? Up in Monte Rio up here. The most powerful people in the world go there. Okay, I've been there many times. Okay, as his guest. He was one of the guys who ran the Grove. So he was a Marine. And then he became, after he got out of the Marines, he became a famous artist, and he had a foundry in Oakland here. But the point is, he was asked then, this about 1968, CIA comes to him and they ask him, since he was a Marine, his brother, by the way, was a colonel in the Marines, and he was asked to be a courier for the CIA. And what his job was, he would have they go on the airplanes with his wrist handcuffed to a briefcase, and in that briefcase were retrieved materials from crashed flying saucers. And his job for 2 years, see, I know stuff that nobody else knows. David Grush doesn't know this. Louis Ellis, they don't know this shit. They don't know shit, okay? So in any case, his job was, he went to MI6 in England. He went to the French, the German. He was even in, this is back in the late 60s. He even went to Shanghai in China and Australia with different pieces of materials for the different intelligence labs to check out, okay? Then at one point, now get this, now here comes the big thing. And it was this guy's name was Colonel Harry Wolf, who sort of came with this stuff. So one day, Colonel Harry Wolf drives up and he has a army duffel bag, which says Roswell AAF on it. Okay? And Colonel Wolf says, Don, don't open it. Yeah, don't open it, right? I'll be back in a week.
Right.
Okay, Don opens it. And inside, there's a bunch of stuff, all pieces of like Roswell, God knows what. But there is the strut, exactly the same strut, which fits exactly Colonel Corso's description of it. Okay, this is in Oakland, in Don's foundry. I can show you photographs. He melts steel. He has hot furnaces, shit like that. He has acetylene torches. He's a man of steel, right? So he takes this acetylene torch and puts the like the torch on just like a piece of the strut. What does it do? The flame just bends, like it bends away like an anti-gravity field. An anti-gravity field, just like the piece of metal is defending itself against, it has like an anti-gravity field that it switches on. You got that? Then,
if I may,
let me finish. Don't interrupt.
okay.
I'll take questions, okay? Because I have a lot of information here. This is intelligence for intelligent people, okay? Details. Now, then he takes the thing gently in his hands, and he's able to crush it. He's able to crush it, just crumple it. It gently gives way. And then when he puts it down, it pops out and gets its original form. Thing is alive. It's nanotech, it's advanced nanotechnology, right? All these machines that they find, they all have that, they are all conscious, artificial, solid state, silicon conscious AI, and which we understand the mathematics, how it works. Okay, this is one of the things too. So there it is. So this is not an inner. It's like an F-35, which has it's not like it's a conscious. It has a will of its own, even little pieces of it, because there's a lot of redundancy, right? It's like a hologram. And so there it is. So that's I also know a lot more about the intact machines. We have intact, as David Grush has said, the U.S. Lockheed Skunk, whatever, they have 13 fully functional machines. But what you have to understand is that these machines allow the humans inside them. And they allow the humans, when the machine flies itself, it's an autonomous, conscious, artificial intelligence. It's a life form. It's a silicon life form. It's what John Lilly called the solid state entities in this book, The Sciences, okay? So that's the kind of technology we're dealing with. So there it is. So that I claim this is not theory. I claim it's not fantasy. I claim it's a fact this is get ready for this, and it's up to you whether you believe me or not. I have no reason to lie. Why should I put myself out like this and lie? And also, I have witnesses. In this case, well, no, I don't. Yeah, I have witnesses to everything. I have two witnesses who were with me at the Bohemian Grove. Two credible, and one is a very high level NASA guy who can confirm what Don Rich has said. Okay, he was a major guy when he died. He dropped dead about 2 years ago in 2022. They had a huge thing, hundreds of people at the Bohemian Grove. The top generals and admirals. People from very Clint Eastwood, all kinds of famous people who are members of the Grove came for his wake, Don's wake. Okay, all right, there he is, and he was a Marine, tank commander. So there we go. Okay, any questions? Now you can ask me questions.
Sure, I'll ask you a question.
Yeah.
Has anyone translated the hieroglyphics on that girder?
That's a good question. I don't know. I just don't know. That's a good.
I heard
hopefully not made in China.
I heard that they had translated it when I was working at DC, and it said, "Point this end toward enemy." Just kidding. I'm just kidding.
No,
that's from a Russian grenade. That's from a Russian grenade launcher in Russian. It says,
let me go to Rick. Rick, go for it, sir.
Yeah, unrelated question to the time travel. Thank you very much, Jack, for clearing that up. It makes sense to me now. And I like your explanation from GR. It's the simplest and most elegant that I've seen for warp drive. It doesn't require fancy strings and all this weird stuff.
No. That's Roger. It's just Roger Penrose. It's just Roger Penrose plus solving the energy issue. The energy problem. That's my contribution. But the basic picture is Roger Penrose.
So my question for everyone, this is unrelated. What's your favorite solvent liquid for life outside of water? If on an alien,
I don't know. I'm not a chemist. What is? Who cares? I don't know.
Liquid methane looks promising. Where it comes to Titan.
Yeah.
That's the only other one I've heard.
That's really cold.
Yeah, but why is that? How is that relevant? Because these machines are, they're just nano.
Yeah.
They're just, they're solid. They're metasurfaces, layered metasurfaces. I don't know exactly what they're made of. That's why we need what I have to do. Okay, so people I know are close to the Trump transition team, and we have advocates in Mar-a-Lago who are trying to arrange for me to meet in the White House with Trump and Elon Musk, after the election, maybe in February or March. And at that point, what I'm hoping to do is to, first of all, convince Elon to stop with his rockets already. He's not going to get anywhere with rockets. He can't go to the exoplanets in a rocket, even Mars. In other words, to start putting his own personal SpaceX money into gravity control with small amounts of energy. This Manhattan Project 2.0. And then to have President Trump, the order in an executive order that to give SpaceX, it could be SpaceX or Texas Space, whatever, to give us access to the intact craft, then we could quickly reverse engineer it. And now that we understand the basic principles, which they didn't have. They didn't understand. Lockheed does not understand what I'm trying to tell you. They don't understand that. And the machines allow Lockheed engineers who are kind of dumb, to get in. They think they're flying it. They give. In other words, the military and the deep state, the military, the military industrial, the Lockheed, Area 50, all those guys, whoever has these machines on loan, their engineers don't know any more than any of you guys, okay? And they are allowed limited access to the technology. That's why they're keeping it secret, because they don't understand it. They're afraid of what they can't control, and that was the whole reason for the cover-up. And that's why a certain military unit, which I'm not going to describe who they are, finally got in touch with me because they were smart enough to realize, oh, Jack understands what we couldn't understand. And that's why I was shown what I was shown. And that's why I'm so confident, because I'm not talking theory. I'm talking, stuff I've seen that,
Well,
that,
yeah. And so let me go to Daniel. He has his hand raised. Daniel, go for
Yeah.
it, sir.
So I just in relation to what Jared and Jack are talking about with the metamaterials there, I had the opportunity to speak with Dr. Travis Taylor 2 months ago, back in November, and he conveyed to me is that he had the parts in his lab in 1994 for a year. And apparently, according to him, he said it was the parts that gave him the idea for the G equals KT, control K, control the universe, independently of other things. Now, you know,
well, where did he write that? Did he ever write that before I did? Can he prove that?
I don't, that'd be a good question for him. I should follow up with him.
Yeah, you should follow up and say, please show us documentary evidence.
But
Just for the record, I first presented the idea in 2011 at the DARPA NASA Orlando conference of the 100-year Starship. And General Pete Warden, who was retired from the Air Force Space Command, who was also a PhD in astrophysics, invited me there, paid my way there. He was the head of NASA Ames back then. And that's where I first gave the paper about low power warp drive.
I saw it. I was sitting there.
Well, and what I think is interesting about this is you were saying that even the parts are conscious.
Yeah.
And Travis said that the parts gave him the idea. And the
All right,
idea,
there he is. Yeah, okay,
and
so
the
listen,
idea,
that's good.
so the idea that he gave them is that the parts gave him are the same idea that you have, right?
Yeah, well, that's good. I mean, I wish he put that in writing, because that's great that Travis and I independently got the same idea. That's good. That's good that he got it back then. Be great if he could prove it. If he somehow can document, official government documents showing in 1994 he's saying stuff like that. Because I independently got it, right? And so that's good. It's good when two scientists with PhDs have the same idea about this problem.
Yep.
That's good.
Yeah.
It's better too, is strong, the fact that we both got it independently. I hope that's true. That's very good information. I didn't know that. Thanks for telling. Yeah, would you get in touch with Travis and tell him to please document that?
Yeah.
And come out publicly with that. Come out publicly.
And let me, if it's okay, let me go to Michael next. Michael has his hand raised. Go for it, Michael.
Yeah. Where's Michael?
Thanks. So 2 questions. So prosaic explanation for the beam, which redirecting the flame around it, could be that it had some flame retardant that turned into a gas.
No. It means what it did. It from I got the equations. It just means it made an anti-gravity shield.
Well, I mean, there's materials you could build that, like various metals and plastics, that when they're hit with a strong flame like that, they off gas, and then it would push the flame away.
No, Michael. I don't think I'm not sure what you're trying to say, but it doesn't sound like you have the right idea.
Well,
It's changing the gravity field, the metric structure, the curvature field around the metal. It puts up an anti-gravity, like a force shield. So any particles get just deflected away from it.
Well, that's something I'd sure love to see one day. But anyway,
yeah, I would love to see it too. But I'm saying this is what Don Rich told me and other people. I wasn't the only one he was talking to. This up at the Bohemian Grove, we had a UFO weekend at the Poker Flat camp. It's a bunch of camps. He's the captain of the camp. Clint Eastwood's camp is next to us, and we had sitting around the campfire, and he's relating what happened to him, and that's why I was invited to Bohemian Grove, because do you know that the Manhattan Project was created at the Bohemian Grove in 1940? Oppenheimer came in 1940 with all these top, Vannevar Bush and all these guys sitting around, and Oppenheimer convinced them to create the Manhattan Project. And that's why, because my professors, were part of the Manhattan Project with Oppenheimer, and that's why they invited me, because they were trying to get Manhattan Project 2.0. And that's what these meetings were about up at the Grove. Okay. And that's
incidentally, we just I was on vacation out there, and I drove past the town of Mercury. So I was out to see Death Valley and a whole bunch of other hiking spots out there just recently. So just coincidentally, it was
No,
nice.
that's not where the Grove is in Northern California. It's in Monte Rio.
Oh, I was talking about the Manhattan Project.
Oh, Manhattan. Oh, yeah, but I thought that's in New Mexico. You were in New
Yep.
Mexico? Oh, New Mexico. Okay.
Yeah.
The test site was is in Nevada.
Mm-hmm.
Los
Yeah,
Alamos,
whatever,
New
yeah.
Mexico, and Bohemian Grove. That's near the coast, right? That's
Yeah, it's
Bohemian
Northern
obviously a
California.
grove of trees and
The Bohemian Grove is Russian River. It's north. It's 70 miles north of San Francisco.
oh,
It's
interesting.
about an hour and a half drive. It's the Russian River. It's Monte Rio, California. Monte Rio. That's where it is. It's
So I
beautiful.
guess
It's
more to the current research stuff.
What?
What is I haven't heard back from Nathan yet, but what's the next steps for the torsion pendulum project?
I
What
don't
needs to happen?
I have to ask Nathan.
Okay.
Nathan came up with a version of it that his students can do in his lab, so hopefully he'll do it.
Did you see there was a paper where they claimed that when you depending on whether you're in the northern or southern hemisphere, when you spin a gyroscope one way or the other, in one case it doesn't lose apparent weight, in the other case it appears to lose some weight on the scale.
Yeah, but that has nothing to do with what I'm talking about. That has nothing to do with control of gravity. That's just classical mechanics, angular momentum conservation. It has nothing whatsoever to do. Don't confuse that with what I'm talking about. No,
Well, how do you explain the apparent weight change in that case?
it's just it's you have to just look at a textbook. It's simply conservation of orbital angular momentum, and it's
it's a very small effect. So I don't know if you can really say it's got nothing to do with it.
No, it's got nothing to do with it. It's not modifying the metric. That's the thing. If you guys don't understand the basic difference between the equations,
the guy was claiming that it was related to torsion.
Classical mechanics and Einstein's gravity field equation are totally separate.
This experimentalist was claiming that was related to torsion, which is gravitational modification. I don't know if it's true. I don't know if I buy the
It's bullshit.
experimental results.
I don't think it's true because there are torsion. In principle, there could be torsion effects, but they're very weak and they wouldn't show up in those conditions. You don't need torsion for that. You just go to classical mechanics books like Corbin and Stell, or you have to find the right kind of book. I mean, rotational motion. It's a complicated problem, classical mechanics. It's not easy. But there are experts, engineers who work in that, and there's nothing esoteric about it. It's just the apparent losses in weight are simply centrifugal forces from rotation. Rotation is more complicated than linear motion. But it's just classical mechanics. There's nothing anti-gravity there.
Well, if we set that question aside, can I ask you? I just want to make a comment. I agree with you that warp drive, forming wormholes, should be a low energy process, especially if you do it, I believe, further out in the solar system.
No, it's wrong. I mean, you may be right, but I'm saying these machines, they're flying around 50 feet above the ground. They're doing it. Don't talk about the solar system. It's right here.
Hey,
hundreds of them in the air right now. People are seeing them in New Jersey and China. They're all around us right now, right in front of your nose.
So that's very sophisticated. I'm talking about kind of boneheaded. I'm talking biplanes. They're talking jet fighters. I mean, sure, but
okay. Why talk about it? The point is they're here now. The stuff that's happening right now, it's also a national security threat.
Oh, I agree. I agree completely.
So it's right. I mean, the contact is happening right now.
The government is doing Maskarova. They're flying around helicopters and their own drones.
The helicopters are trying. Yeah, they're sending up our drones to try to shoot. To see what's going on. But these things, they have superior technology.
Yes, they do.
Well, one other thing I wanted to mention is one last thing. So the Ginzburg-Landau theory for superconductors, it looks a lot like the Higgs mechanism with the Yukawa potential and everything.
It's the
Is
same
it
thing.
possible?
Same thing. It's the same mathematics.
Does that imply that the Higgs bosons are in a superfluid state throughout the universe at present?
Yeah, of course. That's the standard idea. That is the idea. It's called the vacuum condensate. Yeah.
Fascinating.
The universe is basically like a superfluid, a cosmic superfluid. In fact, the dark energy and the dark matter are simply two variations on that. That's what people don't understand.
Huh.
It's different phases of the Higgs condensate, dark matter.
Fascinating.
Because in fact, if you go standard quantum mechanical books, it's this standard stuff. I don't know what's with these people. That if you have a bosons, spin 1, spin 0, spin 1, spin 2, virtual particles, inside the vacuum, they create dark energy. They create an anti-gravity field. According to ordinary quantum mechanics, they have negative pressure. The negative pressure dominates the positive energy density. So, and that's in standard textbooks. Okay.
So,
and then, let me finish. Then
okay.
the virtual fermion anti-fermion pairs are the opposite. So that's dark matter. So wherever there's dark matter, it's a vacuum. It's a quantum vacuum phase where the dark matter is the fermion anti-fermion virtual pairs in the vacuum. They have a higher density than the virtual bosons, and that's obvious because the virtual fermion anti-fermion pairs tend to clump. There's attraction, so they clump in smaller scales, and the virtual bosons, they're anti, so they spread out. So it's all very simple.
Interesting. Very interesting.
Basically, it's simple, but the people are stupid. I mean, smart people are stupid. The guy said they're looking for particles. They're not going to find. Looking for dark matter particles or dark energy particles is the same as when Michelson and Morley were looking for the motion of the Earth through the ether with the interferometer. It's they had
the so if it's a boson-Einstein condensate, it's spread out. They're not going to see localized particles necessarily.
No, it's not. It's not a real particle effect. It's a virtual particle inside the vacuum. That's all. It's a 0-point energy effect. Okay.
Gotcha.
So again, spin 1, spin 2. Spin 0, 0-point vacuum energy is anti-gravity, and spin 1/2, spin 3/2, fermionic 0-point energy is dark matter, is attractive. That's it.
As a follow-up question, then, do you recommend any particular reading material to learn more about that?
There's the book by Maloney, The Quantum Vacuum has this, and also a book by John Peacock called Cosmological Physics. The first chapter talks at page 25 and 26 basically have it.
Excellent, thank you. And then one last thing was, so if there's this Higgs condensate throughout space,
if
there's a Higgs condensate throughout space,
Higgs condensate. What are you saying? Say it.
Okay, so there's Higgs bosons in a Bose-Einstein condensate in space.
Yeah.
So if this is the case, then if there were a way to make the interaction cross-section with the Higgs particles larger, then you could push off of that and sink momentum into that condensate, right?
I don't know, but you got to be careful now. First of all, the condensate, they're virtual Higgs boson, not real. They're what I call off-mass shell. David Chester can explain that. But also, you have to be very careful. Even if you could do something like that, you don't want to do it. You have to read Lenny Susskind, I guess, The Black Hole War. He talks about that. Fortunately, it takes a lot of energy. You don't want to be able to, if you modify if you try to modify the Higgs condensate, you may destroy the universe, the local universe. This is what Martin Rees in his book Just Six Numbers talks about vacuum strangelets, things like that. You don't want to fuck with the Higgs condensate. You don't want to do that because it's just a slight change in that can really be like
vacuum decay, right?
It could destroy our universe, our observable universe.
Okay, I got to talk to Charles.
A vacuum phase transit could be like a Big Bang. You don't want to fuck with that.
Yep. Interesting.
Yeah. Well, guys, I think we have a couple more hands up. So why don't we work through the folks that we have, and then we'll probably close things down for today. Let me go back to HFK real quick. Henry, go for it, sir.
Well, was going to be a question for Jack, but he's meandered off, so I'll hold off.
Oh, okay. Okay, well, let me go to Zoltan again. Zoltan, go for it. Oh, and there's Curtis too, out in the dark.
Same here, sir. This will be to Dr. Sarfatti.
Oh, okay. Okay. Well, we'll wait for Jack to return then. Robert?
Mine was for Jack too.
Okay, we get that. Brendan, I'm guessing it was for Jack.
Okay.
You guessed it.
Woohoo! Okay,
But
let me
it
go to
just-
Curtis. Okay, hold on.
Dip and I are leaving the lab. We were in there, kind of fixing some things. You can say hi to Jim.
Oh, hi, Jim. Well, I hope you guys are able to get the pump thing ironed out. I sent over all the info, so
Yeah.
So,
Did a wonderful job.
Yeah, we'll work on that that pump. I saw your email, so yeah.
yeah,
We'll-
I
we'll-
got that all over to him, so he should have some shipping info now.
Okay, yeah, I'll try to get those phone calls. But yeah, we were working on getting some of the circuits fixed and all that stuff, so that worked out. And yeah, interesting times.
Yes.
Let me see. Oh, there's Jack. Okay, so you know what? Let's go back. Let me go back. We'll go to our order here. Let me go back to HFK.
Jack, question. On any of the information on the strut with the symbols,
Yeah.
were there any reports that the symbols would actually change given that the material is supposed to be conscious?
Yeah, I think that's right. Yes, I think that's correct. I
And
don't recall that's yeah. It certainly is consistent with the physics. Yeah, absolutely. Yeah, they can communicate symbols with change. Yeah, of course, it's nanotechnology. I'll tell you one. Okay, but I can tell you one thing related to that. On one of the intact craft, the fully functional ones, it's sitting in a hangar, like in a U.S. naval base, not far from Langley in Virginia. It's sitting there, and these guys can't do anything with it. It's exactly like what what Corso talks about, and what Rick Doty calls the Cardinal 3. It's like 30 feet, 10-meter diameter, weighs about 3,400 pounds. Classic, the classic flying saucer with the little dome and all that. It's on struts, and it's sitting there, and they try to do things with it. They can't do a fucking thing with it. It's smooth, doesn't have any rivets, doesn't have any way to get into it. No doorways or anything like that. And no hatches. And they do the same thing that Don Rich did with his piece. They put acetylene torches to it. The flame just it sets up an anti-gravity field, like protecting itself. But then, if it likes you, if it likes the human, okay, get this. It'll telepathically communicate inside the human's mind, and it will allow it. And then what happens, you see, like it's just right out of the Matrix. What happens on the fuselage, you first see like a thin black line. It's all nanotech, right? It's all nanotech. Black line, and the thing will open up. It'll open up, and it'll allow the engineer, whoever he is, the voice will say, "Come inside." And guess what? Inside, it's completely empty. There's no machines, basically empty. In this particular case, there were exactly what Phil Corso said, and what both also Rick Doty said. In the center, there like for the grays, this is like the grays, there's 3 small seats, okay? There's a console, and there's like a thing, the grays only have 4 fingers. They have a thumb and 3 fingers. It's a place, and there's like a control panel. Right? I'm not going to say anything more because I got to be careful what I say, what I reveal. But there's a lot more I could say.
But so basically the whole thing flows like a liquid and turns into whatever shape is needed based
I
upon.
don't know. I wouldn't go that far. No, I wouldn't go. No. Wait a minute. I don't know in that detail. I cannot say that. I can't say no, and I can't say yes. I simply don't know about that. But what I can say is that the shape shifts that they see, when in the things in flight, those shape shifts are not real. Those shape shifts are simply gravity lensing from the dynamically changing gravitational field surrounding the ship. It's spending of light by gravity. It's just gravity lensing. That's all. That's just an optical illusion.
No, what I mean is that given the way that you described it opening, strongly implies that it is even though it's a solid, it's basically fluid in whatever form it can take.
I think something like that. I don't have the details on that, but it's
understood.
Consistent. Yeah, you could certainly infer that as being very likely that it has certain, I don't know how well, I don't know to what extent it can do that, but it probably does that. Yeah, because for one thing, the symbols can change, right? So,
right, and a smart material means that it can
it's like a
reshape
small
itself.
material. It can rearrange. Yeah, it rearranges itself. Yes, it rearranges itself. But how much? I don't know.
Yeah.
And then the other question, if the material is conscious, is it now a distributed consciousness when you have something smushed like the Roswell craft, where you have bits and pieces here and there? Are
Yeah,
all
it's like
those
a hologram.
pieces?
Yeah, it's like a hologram. It's like
Right. So all those pieces would be in contact with each other.
Yeah. I think that's the case. Sure. It's a little bit like Terminator, right?
Yeah, the T-1000, right.
Like that. Yeah, it is. I don't know if it can really flow the way into it, but the Terminator idea, yes. And the thing is, there is telepathic. Yeah, the different pieces can communicate because they're all entangled.
Yeah, once in contact, always in contact.
Well, yeah, to a certain extent. See, they're macroscopic wave functions. The point is, microscopic wave functions are very fragile, but these macroscopic, like superfluid, except they're called Freundlich condensates. They're not low temperature superfluids. There's different. They're room temperature. It's called, it's sort of like a laser. It's like a laser, but yeah. So the point is that they're robust. They what's called phase rigidity, and yes. So yeah, so you're on the right track there.
Okay, thanks.
Yeah.
Okay. Let me see. And I'm losing my place. Let me go to Brendan next, because I think you had a question for Jack also, right?
Yeah, and my kids are being quiet for a second, so I should go. Oh, shoot. No, somebody else should maybe go. And just as I said that, I got
okay. Let me go to Robert Francis Jr. Robert, go for it, sir.
Jack, I was wondering what you thought about the alien reproduction vehicle.
I think it's bullshit.
Really?
Maybe. Okay, yeah. I mean, I know there was a lot of stuff we used to work with this guy Gordon Novell, and he was
yes.
Gordon Novell, and they're all dead now. All these guys are dead. And I guess Nick Cook talks about the Nazi Bell and all this stuff. But the point is, I know the real machine, I told you, is empty inside. I mean, it's all, that may now this ARV vehicle may be some kind of primitive, technology that may be, I don't know. But the real stuff, the stuff I'm talking about, you don't need any of that crap.
So my feedback on that is, and this goes back 20 something years. Mark McCandlish was shopping his designs around, asking, I think this is what it is. Do you think that this is Beefield Brown? And I remember telling him in like 2002, I was like, there's no effing way that Beefield Brown could do what you're talking about. And he was like, well, I think it is. So this is what it is, because this is what I drew based on what this guy said. And I'm just like, so yeah, I don't buy into the ARV. I think the ARV was a best effort attempt. Maybe there was something there, but these plans that people publish online, those were based off of poor information that was relayed from a third party. He drew it up based on what he thought that it should do, based on limited knowledge of physics. So
exactly.
I'm not saying he understood how the components all worked. I mean, I've been conducting experiments with dropping magnets, and I found that a dipole magnet falling in the direction of North Pole to South Pole experiences inertial mass reduction.
That's wrong. No, that's wrong. That's wrong. So you don't know anything.
You know that for sure.
Well, you don't know that. You don't know that for sure. Just listen.
I was referring to you.
What are your degrees in physics? What degrees in physics?
That's irrelevant.
No, it's completely relevant. It's not irrelevant.
meters per
No,
second.
no,
squared.
those are magnetic force, has nothing to do with gravity. Okay. And if you don't, and you're obviously not a physicist, okay, and I'm sorry, but we physicists have very strict rules, okay? And
It's
you're
called
breaking them.
experimental data. Boyd
No,
Bushman
it's not.
talked
You
about
don't
this,
you
that
don't
experimental
you're
data
confusing magnetic force for inertial mass reduction. If you knew anything about physics, you would know. Do you know what an atomic bomb is? You know what an atomic explosion is? That's
Nothing
inertial mass
is
reduction,
irrelevant to what I
idiot.
brought up.
You're
This is
listen.
irrelevant to what I brought up.
No, it's not irrelevant.
It goes back to Boyd Bushman, the Lockheed senior scientist.
Oh,
who
Lloyd
talked
Bushman
about
was an
magnetic
idiot too.
field.
Lloyd Bushman's a schmuck also, like you.
For all you know, he could have been privy to inertial mass
No,
reduction.
that's all bullshit.
He might have been.
That's all.
He had a class.
Okay,
I
guys,
don't
let
care.
me,
The
guys,
classification-
let's,
wait,
yeah,
the
let's.
classification is a bunch of crackpots like you stealing government money. You know, because everybody's an idiot.
I dropped magnets and I measured. I did it the same with.
Okay, yeah,
four
let's,
different
guys,
magnets
here,
and
I'm
a
gonna,
control object.
okay, guys, I'm gonna mute you both out for the time being. Guys, I think, you know what, it is
I think
20
we're
minutes
done.
after 7. Yeah, I think that we're done. So I am going to close recording down for today. This has been APEC for Saturday, January 4th, 2025. I'm going to stop recording. We will go out on a high note, and I will see you guys again in a couple of weeks.